That spirit of open source is beautifully captured for me by the word Ubuntu. So that's ultimately why we chose it. You could take this, you could look at it a different way. The measure of your success and the measure of my success is their success. And it kind of doesn't matter who they are, right? That's the beautiful thing about open source and about Ubuntu. Our contribution to open source is not just the obvious thing that we contribute, but it's the amplification of all of the contributions to open source that people find easier to get or can build on more reliably or are encouraged to explore and enjoy because we brought a different take to it, right? There is a community that builds something, right? Ubuntu. And often the temptation is to sort of say, well, that's what it's all about, right? This feeling of being part of something. But for me, the other half of this is all of the people doing brilliant things who don't identify as Ubuntu, right? Innovators who do things we wouldn't even know how to try, how to do. So I think about silicon companies, right? People who are working at an entirely different kinds of abstraction, entirely different, with entirely different constraints and challenges, right? Doing kinds of innovation that, to me, are completely mysterious, right? And yet, by partnering with them, right, and bringing open source to their silicon, right, we unlock the future faster together, right? They bring us great big piles of open source to do things on brand new silicon, right, faster, sooner, right, because of who they are, right? We can be Ubuntu. I think of all the people who make devices, boxes, personal boxes, server boxes, data center boxes, IoT boxes, right? Bring open source to those boxes and magic happens, right? But conversely, bring those boxes to open source and magic happens, right? Our impact is amplified by the partnership that we have with the people who build the actual systems that we all use. Think about the public clouds, this extraordinary new kind of compute, right? This seemingly endless, bottomless, although I'm told it doesn't feel that way if you actually work there, but from where I stand, kind of endless, bottomless compute capability, right? That enables people to do incredible science, right, in a day that they might have waited 10 years to get a research grant to do, right? Or wait for the university supercomputer to get built, right? Or entirely new kinds of business to be built, right? Things that we never would have dreamt of because of public cloud, because of open source. And then I think of the upstreams, ISVs, the developers, people who are doing things that we're not going to see for another 3 years, another 5 years, right? People who are drawing from the well of open source and pouring their own talent, their own ideas into that well one way or the other, whether it's as code under an open license or as inspiration for code under an open license, right? Again, we cannot hope to do what they do, but we can enable them to reach their audiences faster and better. We can enable them to ship software, right, with more confidence immediately and more confidence in the long term, right? And they will contribute new ideas, new things to us. When Ubuntu got started, those amongst us who had brand new laptops had one core running at about a gigahertz, right? Brand new laptops. And yet today, you run that on a coin cell. It's incredible. I believe the next 20 years will be equally transformative in terms of the ambition that people have to create things we can't even dream about today. But they will do it because of open source and on open source, right? And it is a great privilege for me to be working right in the middle of all of that, right? Living a little bit vicariously through the stories of what people do with open source, the crazy challenges they face, and the ways in which open source enables them to dream those dreams. Canonical didn't really exist for a long time. Right? It was only the Ubuntu community. And one of the interesting things has been to figure out how could we find a place and a relationship between a company and a community that would amplify the impact of both of those. In discussion with the Community Council this week, we were talking about that relationship, and it really reminded me of the fact that in the founding of Ubuntu, there was this idea that, well, we already had exceptional communities that were resiliently and resolutely purely communities in the way that Debian is, right? And they're pretty extraordinary. And we already had companies that were exceptional, right? Who were focused on open source, the Red Hats, the SUSEs of the world, who had really blazed that trail, and credit to them for doing that, right? We need to find a new space. We need to find a way of working, right, which would be genuinely different and genuinely new. And so there have been many times in our history when people have said, oh, why don't you just do this because that's what everybody does? And I would say, well, because they've already done it. We're not add anything if we don't think differently about that relationship, right? Those relationships are difficult, right? All relationships can be difficult, right? People never want exactly the same thing. People never see the world exactly the same way. How dull if they did. We've all had different experiences. I think it's a real credit to everybody concerned that we have found this balance, right? It's something that brings me great joy to see people who work for Canonical and people who do not work for Canonical having an intellectual and emotional discussion about technology without necessarily knowing or caring whether the other person has a life, no, maybe that's the wrong term, but an agenda, right, beyond solving this problem, right? I think it's a real credit to all concerned that largely we see, that's what we see. This is our new London office at Canonical, and I was delighted that the very first event that was held there was the Cephalacon for the Ceph community, right, with people from a wide range of companies and community interests, from the kernel all the way up, right, hashing it out, haggling it out, bragging a little, boasting a little, pushing a little, right, just like we like it, just like our very, very earliest summits and conferences in very different circumstances. Innovation happens everywhere, right? There's so much compute. There is so much diversity in the kinds of compute. Public cloud, data centers, edge clouds, tiny little things, workstations, right? None of us can know the whole of it, right? But I would ask us all to try to find what we have in common, right? You may be across the table from someone who's trying to get something done on a mainframe. You might be across the table from someone who's trying to get something done on a supercomputer. You may be across the table from someone who's trying to focus on a personal computer, a desktop environment, right? You all have something in common, right? Wherever innovation happens, right, we want to support that innovation, accelerate that innovation, and enable that innovation. Not just wherever in compute, but wherever in space too. This is a very empty new Beijing office, where I hope, right, we can get members of the community, open source community, right, who are equally passionate about everything from AI to health to, well, whatever they might be passionate about, right? To broaden our community, keep it an open community, right? And make sure that the benefits of open source reach every corner of the globe. We are different. We want different things, right? It's a great joy for me to see leaders who are driven and who are passionate and who are aware of details from the lowest level in the kernel all the way up to the highest level in terms of user experience or domains about which I'll never, have any deep understanding. To see those leaders able to craft something that expresses their vision, right, enables them to push into their audience with much of the muscle that the whole Ubuntu community brings, right, without necessarily distracting all of us, right, from the things that we care about. I want to thank everybody who showed up and said, I want to take Ubuntu in a different direction, right? But I will work together and make that a plus, right? Ubuntu plus. That's very difficult. That is definitely not the easy way to do it, right? Either technically or socially, right? That is not the easy way to do it. But in the long run, that's the way that wins. Over the last 2 years, we've very carefully and very deliberately been enabling people to think about Ubuntu as an enterprise platform, as a mission-critical platform. And that was always going to be a very sensitive, delicate question, right? How are we going to do that? What are we going to take away? What are we going to lose if that happens, right? Inside Canonical, in the Ubuntu community, in the wider audience, right? I felt, others felt, we needed to be very, very careful not to spoil something that we all believe in, right? I want to thank everybody who's played a hand in shaping our thinking in how we do that. And the reason I think this is important in the community is because whatever your vision, whatever your audience, we want you, I want you, to feel like you can be pro. Edubuntu, pro. Kubuntu, pro. Right? There is no reason for a community project not to aspire, right, to deliver to that standard. And because we've done this the way that we've done this, I really believe it's possible. And I'd like to go further. I'd like people who are open source innovators or innovators on open source to feel that because we've done this way, even if they have nothing to do with Ubuntu, even if they have no interest in identifying with Ubuntu, if it's helpful for them, it makes it easier for them to be pro, right? I'm sure we have a whole bunch more to do, but I wanted to share that that's the spirit in which we're doing it. This is the question. This is the question I ask that we ask, right? What would be amazing? Everything's difficult. Everything's complicated. Some things very controversial, right? Being different is controversial. But in the end, to do something that you feel is really amazing is worth a little bit of controversy, a little bit of sweat, some blood, some tears, right? So I hope whatever it is that you came here to do, or whatever story you came here to tell, right? I hope that people are going to come up to you and say, that was amazing. And I hope that you'll go home thinking, I'm going to make it even more amazing because of someone I met, something I heard, something I saw, right? Or something that came to me while I was staring at MC Escher. On that note, welcome. I hope you have a great weekend, and I'm super excited to see at least one track at a time of everything you have to say. Thank you for coming.
I also want to introduce our next speaker, but before that, I want to thank whoever couldn't make it here today to be amongst you. We have quite a few people who did sign up for remote registration, are tuning in, and are watching a lot of what's happening through live stream. So if you're tuned in, thank you. If you're here, thank you as well. Our next speaker is a software engineer at Igalia, where she works on the Servo browser engine. She's based in Germany and is interested in the web browsers and engines. I would like to welcome to the stage Rakhi Sharma.
All right. Hello. Hi, everyone. What a nice crowd. Wow. OK. Hi, I'm Rakhi Sharma, and I'm an open source software engineer working on Servo. I work at Igalia in web platform team. I'm also a Servo technical steering committee member. And if you want to find me on internet, on GitHub, or anywhere on internet, I go with username ATBRakhi. Even before I go into the project itself, I want to know how many of you have heard about Servo project. Wow, how many of you work on or with Rust programming language? Great, great. Wow, what a great crowd. It's a perfect mix. I'm so happy to see some hands up there. Cool. So, OK, this is not working. No worries. I can go back. For the folks who don't know what Servo project is, we like to call it web rendering engine for the future. It is written in Rust with WebGL and WebGPU support. And it is adaptable to desktop, mobile, RPIs. And you can embed Servo in applications. Servo had a long journey so far. Some of you might be very curious about what is happening to Servo, where it is right now. Because if you look at the journey of Servo, it's like it starts at 2012. It started at Mozilla Research, and it had pretty good time around 2016, 17, 18. It was at its highest. Folks were working on different parts of the servo, adding WebGL, WebGPU, WebXR, like bits of almost everything. But around 2020, things went a bit south when Mozilla layoff impacted the servo team. And around the same time, it joined Linux Foundation, and talks about restarting servo started. But who will start servo project? If you have worked in open source community, or if you are familiar with browser world or rendering engine world, you know it is a big project. And even though there were some folks from the original team trying to maintain this project in their personal time, if you have worked in open source project, you know that working on such project in your personal time is not enough, even just to maintain this project. And to restart this project, one of the biggest blocker was to find folks with experience. And I couldn't think of anyone better than Igalia, maybe because I work there, but also they have quite a lot of folks who have experience with web rendering and web rendering engine and browser itself. How many of you have heard of Igalia in any way? Wow, you all. Okay, you all surprised me. Thank you. It's good to know that you all already know about Igalia. Igalia has been in pretty much almost everywhere when it comes to open source. So some of you already know that Igalia contributes to almost all the rendering engine, WebKit, Chromium, and now Servo. So in 2023, the project was restarted at Igalia, the team was formed, and in 2024, here we are continuing the project and doing quite a lot of work around. Even when I say that at Igalia, we have folks who have decades of experience working on browser and rendering engine. Even one of my teammate, Martin, he has worked in Servo during initial days, and he still works on Servo right now, so he has huge experience. And even another teammate, Oriol, he reads specification like it's his native language, and the implementation he do after the specification reading is super crazy. I mentioned that Servo started in 2012, and Servo and Rust has a pretty interesting story. I'm not sure if many of you know or not, but Servo and Rust started around the same time, at the same place, Mozilla Research. And when there was a team working on Servo, and there was another team working on Rust, and they were helping each other move in a way where Rust programming language team will implement features, they will use that feature in Servo, and then they will see how it is working. Feedbacks will be exchanged, and based on that, they will improve Servo as well as the Rust programming language. Now, Rust has moved on to become a pretty mature programming language, while Servo had some slow times, some ups and downs, but I'm still very happy to see where Servo is right now. Contributions over time, if you see there, it's pretty hard to see where is 2012, but you can imagine from the 2014 where it is. And you can see, like earlier I mentioned that around 2016, 2017, we had like pretty high times for Servo where lots of folks were working. And then you can see around the 2020, it went pretty much down, 21, 22, pretty much no work there. And then around 2023, the project restarted again, and some work has been done, and we are continuing that work. In 2024, you can see that we are pretty much back to how it was around 2015, and I would love to see this project go up like how it was in 2017 and 2018. I have been talking about what happened before, but it's 2024, and where we are right now, we are focusing on embedding, layout, and benchmarking. These are not just three specific things that we are focusing on, but there are lots of things going on. We have folks who are focusing on web GPU support, WebGL support, but today I want to talk about these specific things because I personally feel like this is most important for the folks who wants to try out Servo. When I'm talking about embedding, I want to show you some examples around what are we doing with embedding, how we are working with other folks who are wanting to use Servo. One of our aim with embedding is to make Servo easy enough for other folks to use. We as developers can add lots of features, and if we are not providing a way for you to test Servo, how you are going to know what is happening? Sure, if you're a developer, you can go and set up a repository and clone and run the project and see how it is happening. But we want to make it easy for folks who don't want to go through that pain. And we have come quite a long way right now, because we started the embedding work end of the year last year, and I will show you some examples how it is happening right now. And so far, we have managed to run Servo on embedding devices, RPIs, and OpenHarmony. We also have it running on Android, but for some reason, I don't have Raspberry Pi with me today. I always have it. I have personally run Servo on Raspberry Pi 400 and 500. I wish I had it today. Just to walk you through some examples how and who we worked together with to integrate Servo or embed Servo in the projects. First example I wanted to show you is the Tauri, Rai, and Servo. Rai is a web view library for Tauri, if you don't know. But UV from Tauri team, and it's UV and his team worked with Servo team together to embed Servo. This work was sponsored by NLNet, so thanks to them quite a lot, because it wouldn't have been possible. This was one of the initial work that we did for embedding part. And if some of you are front-end engineers, it is as easy as that you write some HTML, CSS, and the rendering part is taken care by Servo. And as a user, you don't even need to worry about the integration, because the integration part was done by Rai. And if you are curious about this project, you just need to do one thing. You just need to find the Rai repository on Tauri's GitHub, and you will find the branch Servo where they did this experiment. Another example I have for you is Verso. Before I mentioned, UV and his team worked with us to integrate Servo in Rai. UV went ahead and he decided to build a browser using rendering engine, Servo. And it has been coming so far very interesting. It is very early stage, but we are so happy to see folks taking more steps to try out Servo and see how it is happening. If you are curious about Verso, we have a blog post where UV talked about how they are making this browser and what are their plans with it. I'm also going to show you later how it is happening. Another example I have is Deoxys. Deoxys did a bit of interesting thing. They did not take the whole rendering engine and embed it in Servo. What they did is they took one small part that is Stylo, and then they tried to use Stylo with Blitz, and it worked great for them. I know that some of you might not be like, don't talk about CSS or something, HTML or something, but this was very important part, because we are talking about a rendering engine, and the most important part for a rendering engine is to render the layout and to render a website. Doesn't matter where you use the Servo, where you are using, which device you are using on. One of the most important work is to render the website that you are trying to load in a nice way. So they took Stylo, and then they are using it with the Blitz, and they use the Stylo for CSS styles and the match and the selectors matching. We also learned from this experience when an organization or developers come to us and ask questions about the problems they are having. Let's say they are trying to embed Servo somewhere, and then they have problems. They encountered some problem. The features some features that we don't support yet. So they come to us and say, hey, this is not supported. Can you help us? And we try to help them in a way. And after working with Tauri and Dioxys, we realized that we can make their life a bit easier. If you have worked with Rust and you're familiar with cargo and such, you know it is complicated when it comes to dependencies. And Stylo was part of Servo within the same repository. We learned from Dioxys' experience. We thought maybe there are other folks who would like to do similar things at Dioxys. So what we did is we took out Stylo from Servo project and then created a separate repository so that if one of you decide to use, I just want to use the Stylo part of Servo, I don't want to use the whole Servo and build some application or build something out of it. It's easier now. And one of the surprises for us was KDAP-Qt. This was something that came out as us to surprise because we didn't know that they were doing something like this, or they were trying servo rendering engine. We only got to know when they decided to publish a blog post and show how they did it. So what they did was they tried to run servo inside a Qt. They have a CXX Qt library that they used as bridge. And in previous examples, all the examples that I have shown you, Dioxys and Tauri and Verso, it was a Rust project trying to integrate servo that is also a Rust project. KDAP-Qt was different because they were trying to use servo that is written in Rust in a C++ applications. So CXX Qt that they have was an interop, that is an interop between Rust and Qt, came to their rescue, and they were able to integrate servo pretty nice, as you can see in the screenshot. Not forgetting about the mini browser. This is today, right now, if you go to servo website and download the nightlies from there, this is what you're going to see. This is what you will see if you install it in your desktop or even on Android. And this was one of the work that we did initially that motivated us to do more work on the embedding side because we received so much input and love from community for this. And just to show you a bit how it was, okay. Can I do this? We have quite a, yeah, you can see it perfectly. This is how it looks. We have been doing quite a lot of work. We have been adding tabs and such. Just so you, I'm just going to copy this here and probably paste it here because I want to show you some demos, how servo is doing and what you can test on servo. We have this demo website where what we do is like if we come across something that will test a feature of servo, we just put that example here so that if you, let's say if you want to say, I want to check FPS, how servo is doing, right? So you can go here and see how servo is doing. Right. We have compared it with like other rendering engine as well, and it is pretty interesting. And this is cat portal. I'm not going to open it. I'm a cat lady, I think. I'm very tempted. This is my photo gallery where you can zoom. So the idea behind all these demos is to test servo's feature because I just opened the website and it is rendering fine, and you can see that, okay, that means that layout is pretty much working fine. So we have some of the demos here that you can test. If you don't have a Raspberry Pi, but you want to see how it is looking on Raspberry Pi, we have some recordings here that shows like how it is looking on Raspberry Pi as well. And earlier I mentioned that you can find the nightlies on our website. You can find all the nightlies here, and macOS, Windows, we support almost all the desktop. We have Android and OpenHarmony as well. If you have Android right now, you can download and check out servo. and report bugs if there is any. And then if you're curious about how someone is building a browser using rendering engine, we have a very cool blog post that was written by my colleague Dylan and UV, who initially wrote this blog post about how they are building Verso. So definitely check it out. You can find everything on Servo website. But I am going to go back to the mini browser and talk a bit more about layout. I will be very quick on this part. There are lots of layout work going on. We have been adding floats, table, flexbox, font fallback. If some of you, I don't know if we have folks from Japan, China, Korea or not, or if some of you know this language, but you can see that we have those, we have added support for this. We have added support for right to left languages. And on the left side, you can see all this small work. Like this is something, even you are a front-end engineer, you don't really use it on a regular basis. But it is important to note that how big of a role it plays when you are browsing web. And it is not just limited to floats, flexbox, and tables. There are small things that is like implementation is pretty big, but still they play very important role in that. And after the layout work, we have benchmarking. We had like quite a lot of folks asking, how is Servo doing? And what is the plan? How I can see why things are taking so much time, or what is causing it to slow down? And recently, we landed new experimental profiling support in Servo, where you can see in this screenshot, what I did was just ran a small demo and see, okay, how and which function probably is causing this website to slow down, or what is taking so long time. And it was like as simple as just uploading the profile and just me going here, checking out what is causing the problems here. I just took a screenshot to show you here how we can track down to the functions and what is taking so much time so that later we can improve. This was one of the things that we have been asked from community quite a lot. So I'm very happy to see that it has landed, and we have been instrumenting across all over the code base right now. And one of the other requests from the community was to like, how is Servo doing as compared to other rendering engine? This is the question that lots of folks are asking. So what we did a report on how Servo is doing. And if you are interested in finding that report, you can always find this on Servo Wiki. We have it published there. You can also see how a particular part of Servo, so a rendering engine is filled with quite a lot of steps, right? You have JavaScript part, you have JavaScript engine, you have layout, you have scripts, and quite a lot of things. And you can see how it is performing as compared to the other parts of the rendering engine. This was the work we are doing. Earlier, I said that we see Servo as a rendering engine for the future, but that future is not too far. At least in my opinion, it is not too far. We already have Servo running on Android. You can, right now, go to servo.org and download the nightly version and run it on your Android phone. You have we recently landed support for OpenHarmony. We had one of the contributors sending us quite a lot of PRs, adding support for OpenHarmony. And we worked together with them to land support for OpenHarmony and to also add how to do it for other contributors if they also want to run Servo on OpenHarmony or on Android, how you can build it and how you can even contribute to the code base on our Servo wiki. And we actually have a Servo book where you can really read about all the parts of the Servo to understand what is happening in script, what is happening in the layout, and also how to contribute to the project itself. In the opening talk, Mark emphasized on the importance of community. And I personally also believe that open source project is nothing without its community. So while as a project last year we decided that it is very important for us to let other folks know what is happening with Servo project, what are our plans, and how we are taking it out of the maintenance mode. This year, we decided to take an extra step and decided to also give back to the community. We participated in the last round of Outreachy. If you're not familiar with Outreachy, it is a 3-month paid internship program. It happens twice a year. We already participated in summer, and our intern, Ari, helped us landing support for DevTools. If you have ever worked with layout or just the front-end part, you know how important DevTools is. And we are participating again this round in the winter. We are looking forward to having some new folks contributing to Servo project. And we already have lots of contributions coming in, actually. So we are also looking for new contributors. If you are interested, please check out Servo Wiki for sure. And what is next? While what is next part is something where I personally really like to include the technical part. I have included the technical part, but it is in the bottom, because this time I wanted to include some other parts that is non-technical but as important as the technical one. We want to grow the health ecosystem, and we want other organizations to join our effort. We had few organizations and individual contributors who wanted to try Servo and embed it into different applications and see what they can do with it. And we want to continue doing this. Of course, I invite different organizations. If you are interested, please reach out. And the most important part, the public and private sector funding. That is also very important. We are an open source project, and projects like Servo, and there are also many other open source projects that need funding for sure. And next year, we also want to continue working on performance, benchmarking, and there are lots of HTML and CSS features that is missing from layout and the rendering engine itself. So we would also love to continue adding those features. And yeah, you can also support us. You can sponsor us on GitHub. You can also donate to us on Open Collective. We already have 350 folks who are donating and supporting us. If none of that works for you, you can also email us at join@servo.org. And if you are interested in contributing to Servo, you're just one step from it. You just need to check out the Servo repository on GitHub. We have Servo book there. We have Servo wiki there. And if you get stuck even after reading the wiki or the Servo book, you can always reach out to us on Servo Julep chat. We have lots of contributors and the maintainers helping other folks to send PRs and to work on different features. And we are always looking into growing the community around the project. We are also on social media. Find us. Thank you for coming and listening to me.
Thank you so much. So if you have any questions right now, I think we have maybe chance to take 1 or 2 questions. If you'd like to ask a question, we have microphone 1, microphone 2. You can just stand up and walk to them and ask your question.
Or you can, okay.
Okay, let's just wait. Yes, we have a question, please.
Can you tell us a bit more about the experience you had with Outreachy, both for yourself and for the intern?
I think, okay, yeah, it is working. Yeah, sure. We had a very interesting experience when we applied. I think, I guess do you want to know about the contribution part or the whole internship program part?
No, I'd like to hear what the experience was like for you, what you learned from the experience, for example, as an open source project.
Yes, for sure. I think one of the important things that we learned was we need lots of easy to fix issues, and we need to be available in the start for the folks and for the new contributors. Because the folks who are coming to or participating in Outreachy program, they are either early career folks, or they have breaks in your career, or they are trying to change career. So it was important for us to be there for them. And during the internship, we had a great experience. Our intern, Ari, was very active in sending pull requests and asking questions. That was the most important part. On the organization side, for mentors, I think Outreachy made it very smooth for us to put our project on their website, to participate in the program itself. That was more on the organization part, but overall, we had great experience, and that's why we decided to participate again in this winter round as well. Welcome.
Thank you for your question. And we have time maybe for one more question. Yes, please go ahead.
Hello, thanks for the talk. You mentioned that there is a Qt binding for Servo. My understanding is that there's going to be a performance impact likely between translating from Rust to C++, because there's going to be more bindings in the way. Nodes are still binding with the Chromium engine it uses, but is there a significant performance impact compared to just having, say, a different Rust native UI in Qt, or is it about the same?
So just to clarify, the binding is not maintained by us. It is CXX Qt that is maintained by KDAB. I think they are the folks behind this binding. And also, it is important to note that Servo also have mod.js that also has binding. So I'm pretty sure there are some performance, I won't say issue, because we are still pretty much at experimental stage, right? So performance is the second thing. Getting it to work is the first thing. So I'm pretty sure the KDAB folks had issues, but I don't remember them mentioning either in their blog or to us that they had performance issue.
Okay.
Thank you.
I think that's all the questions that we have. Thank you so much once again.
Thank you.
If you want to, I think you can. So, okay, I see there's some motion happening around. We're going to be starting our next session now. I'm personally interested in this topic, probably for quite some time. Now, who remembers when the first motion pictures came out? I mean, probably no one here. It was so long ago. You wouldn't be alive. Opinions vary, but also history is also very divided. But it's supposed to be around the 1890s, 1880s. Since then, there's been a lot of evolution, in the same way that our technology has evolved, the way we approach motion pictures and how we produce them has also evolved. And our next speaker is very crucial for the governing board of the Academy Software Foundation, where they develop the use of open source software in the motion picture industry. And please join me in welcoming David Morin, the Executive Director of the Academy Software Foundation.
Ahmed. Thank you. Thank you, Ahmed. Thank you, Canonical and Ubuntu. Thank you, the community, the Ubuntu community, for welcoming me here at your conference. I'm glad to be here. I am looking forward to get to know you. And I'm here to bring a bit of information about our community, the open source engineers that work in the motion picture industry, developing software of all sorts and kind. There is a strong open source undercurrent in the motion picture industry. People sometimes are surprised to hear that, but there's a reason for that, and today I'm going to give you the background. We're going to talk about a bit of the history. As Ahmed said, the motion pictures have been there for a long time and have gone through many technology disruptions over the years, technology changes, and every time the motion picture business found a way to use those new technologies to make them make better movies. And so that's what we're doing. First, however, because it's motion picture, I have a demo reel, and because it's motion picture, it's loud and it's obnoxious and everything, but we're going to show it to you right now. All right, so what you saw there is some examples, some shots that were done using our open source libraries by our member companies, the studios that make motion picture. What we're going to do today, in the next half an hour, a little bit more than that, we're going to look at open source in motion pictures, a bit more of a history. What is the Academy Software Foundation? What we do. And we're going to look in some details at the high level what our open source projects are doing and how you can participate if you are interested into dipping your toes in the motion picture business. As with open source everywhere, it's a meritocracy. It's those who do that are rising through the ranks, those who provide the code, and when it's useful, then you become a filmmaker. That's as simple as that. So every developer that works in the motion picture industry is a filmmaker. They have to think like a filmmaker for the people the artists that actually do the movies, and that's how we get to produce software that matters. But first, open source more generally in the motion pictures, where does it come from? So the big, of course, grandfather of all open source in a lot of industries and in motion picture as well is Linux. So the Linux operating system has been in use in the motion picture industry for more than 25 years now. The reason why the motion picture industry chose Linux is because in the early days of computer graphics, the Silicon Graphics company that was based on IRIX, their own operating system, was the provider of early graphics workstation that were producing image or able to do so. And so the motion picture industry had embraced that company products. And when the company went under, there was a choice to be made, an important choice. That was one of those moments in time where no one knew where it was going to go. The leader at the time went to all the companies having an OS and asked them if they would dedicate some resources to the motion picture industry. The fact is that the motion picture industry is not a very big industry. It's very visible because of the products that come out of it, but it's not very large. And so there was not a lot of strong commitment to the motion picture industry from the existing commercial operating system, and there was Linux. And so the studios decided that, okay, if we're going to do this, on our own, we're better choose an operating system that we can modify, adapt, and build on. And that's how the motion picture industry went with Linux. There is a lot more to say about that. There is a report that has been done. That's what I had here on this slide, the VFX Animation Studio Workstation Linux report. You can download it at the vfxplatform.com. The Visual Effects Society Technology Committee produced this. They're one of our sister organizations in the motion picture industry. They're helping a lot in various aspects connected to open source. They produced that report. You can go and download it. This image, this graph here comes from it. You can see that of all the different distribution of Linux that are used, Ubuntu is right there for a solid 10% of the use in the motion picture industry is Ubuntu. And you can find out more. Please download this report to have more information. When we come to other open source projects and libraries other than Linux, today there is a strong ecosystem of those projects, and we have a landscape, the Academy Software Foundation landscape on our website, where you can go and actually double-click on any one of those boxes that you see there that represents the various software divided in categories, open source software, and you could get down to their GitHub. It's this kind of a central switchboard where you can go see about 150 of the most relevant open source projects in the motion picture industry. I want to talk a little bit about the Science and Technology Council of the Academy of Motion Pictures. It's lesser known activity of the Academy of Motion Picture. Of course, we know the Academy for the Oscars telecast that they do every year, but there's always been a science and technology aspect to the Academy. Sometimes it has been dormant when there's periods of stability, but every time there's been a new technology that disrupted the motion picture business, the Science and Technology Council was called upon. They're kind of the Avengers that are called to come in and do the work and analyze a difficult situation. They were called when sound came to the motion picture industry in the 30s. They were called again when color became a thing in the 60s. They were called again when digital in general took over and the industry moved from shooting on film to shooting digitally. And they were called again when open source started to play a large role in the industry. This image here represents a meeting that was done in 2016. Something had happened with the open source libraries that were developed in motion picture. There were a lot of them. Some of them were critical to production, and they were extremely important, and that had grown organically. There was no coordination to it, like often is the case in open source. Engineers who believed that what they were doing, it would be maddening if it was repeated 6 times different places in the industry, and that everybody should work on this thing, would go and ask their management, I want to open source this. Sometime management said yes, sometime management said no. It depended on the management, depended on the legal folks that were approving that, their knowledge of licensing, software, etc. But a lot of software made it through, and some of it was critical, and a few maintainers left the industry to go to Silicon Valley or other places, and suddenly there was a few projects that everybody was using. There was no one at the wheel, no one was checking PRs, there was no one to maintain the project. So studios started talking about, okay, well, what do? I need to do these developments? Do I branch? Do I go and do my own thing? And which would have been terrible and going back to the prehistory of software in the industry. So the Academy Science and Technology Council assembled this investigation that lasted 2 years to look at open source software. And to make the story short, after discovery, the investigation concluded that better support should be provided to the open source software developer in the industry. And the Academy Software Foundation was created at that time. So the foundation is a collaboration between the Academy Software Foundation and the Linux Foundation, and the goal is to provide a neutral forum for open source software in the motion picture and broader media industry, to share resources and collaborate on technology for image creation, visual effects, animation, and sound. The Linux Foundation had been an advisor. We called during the investigation to many experts about open source who could look at our situation and give us advice. The Linux Foundation proved to have a solution for us that was ready to implement, and the Linux Foundation, as you know, takes care of Linux. As you probably know, it also it's an umbrella now for hundreds of different foundations and projects, like the Academy Software Foundation, where they provide the infrastructure that they develop to support Linux to any other open source project that is ready to come on board. So the foundation is a collaboration between the Academy of Motion Picture and the Linux Foundation. The mission is to increase the quality and quantity of open source contribution and to provide a governance model, a legal framework, and a community infrastructure so that to lower the barriers to entry. Before, if you wanted to contribute to an open source project in motion picture, you really had to dig deep and in order to find out where the GitHubs were, and this was, you had to do a deep research to get there. Today, we believe we're much better. So with regards to the industry, to the higher level overview about open source and entertainment and the motion picture industry, we produced this report at report.aswf.io that gives a broader view about why we created this, and it's essentially a set of interviews with the CTOs and the technology folks who participated in creating the foundation, why we did that, what our hopes are for that, and where it goes. So I encourage you to download the report. If you have some time, it's a good read. So we believe, like you believe here, that open source is a better path to technology development. And what we do at the foundation is we support the open source community by having some events. We do project marketing for the project. We provide an infrastructure for the project. We do the founding for the foundations and the project, training, education, legal assistance, which is quite important in all industries, but in ours in particular. It came in one of the first things we did when we created the foundation is get the legal counsels of the studios and the vendors to the studios all in a room to agree on and educate about open source licensing, because often that was a roadblock when a project wanted to use an open source project. Many lawyers were aware and savvy in intellectual property and open source, but some were not, and it was hit and miss if projects would be approved or not. So the legal assistance part that is provided by the Linux Foundation really helped smooth the land on that level. So we do standard facilitation, open source evangelism, and more. This is the timeline of our foundation. When we started it in 2018, you can see to the left the investigation that ended in May of 2017, and then in August 2018, we had our founding event. You see the name of the companies that joined, the founders on the left side. And then you see the chronology. I'm not going to go through all of it, but the projects that joined and the new members that came in, and the chronology of our conferences. We have two of them, Open Source Days and Open Source Forum, that we do every year. One is with SIGGRAPH, in conjunction with SIGGRAPH, which I assume that many of you know for the computer graphics. The other one is in February as a member summit. So our membership is made of 40 companies in 3 categories. The first one, the premier, are the ones that have the biggest commitment, both financially and in terms of engineers that they provide to the foundation. The premier members also have a seat on the board, and they are really the one who help decide where we're going to go next. They're my boss. They tell me what to do and where to go. They told me this year we have to focus more on engineering contributions, and that's one of the reasons why I'm here, to come and speak with you about the foundation. The general members have a lesser contribution in terms of dollars. They don't have to provide an engineer. The premier member have to provide one full-time engineer equivalent to the foundation. So that gives us already 20 engineers to start from. It doesn't have to be one single engineer. They stay at the companies that they're at, but it can be a combination of people working part-time on different projects. But we expect our premier members to be present in our lists and our Slack channels to contribute to our projects. And then we have the associate members who are other nonprofits that come to collaborate with us. We talk about all these things in terms of structure and all, but really what matters is the people, always, at any level. And this is the governing board that is directing the Academy Software Foundation today. They have a group of governing board alternates that can replace them if they cannot come to the meeting, etc. And this is the Technical Advisory Council. So these people here, they are the mind and the heart, the beating heart of the foundation. The whole foundation is structured around the engineers and to clear the way for them to do what they want to do, what they have to do, what they decide to do, and to provide support and financing and all that's needed to really remove everything that would hold them down. So really, it's the center of the foundation, and that's the structure. So the Technical Advisory Council is at the center. All the projects, we have 15 of them right now, are each one of them have a technical steering committee with a chair. All those people meet every 2 weeks to talk about the business of the technology business of the foundation. Every project does a yearly review that takes a number of those meetings, and all the action is at the Technology Advisory Council level. The governing board is there to provide the financing, to provide the structure, the legal aspect of things. We have an outreach committee that does marketing and the events that I mentioned. And they, all together, we work to the betterment of open source in general and our project in particular. We also developed a CI platform. We have a CI working group that has been hard at work to develop one platform where all of our project would be developed from, because each one of these projects came from a studio or a vendor that had their own built infrastructure. It was important to develop one that is open source itself and that can be embraced by smaller studios who want to start developing open source software themselves and contributing. And so we do that as well. So our projects, I put this QR code here because I'm going to talk at a high level, and you may find that I'm not getting into enough details. So if you go to that link here, you can go straight to all of our projects, and you can check their GitHub. You can go as deep as you'd like. So I invite you to check this out as I'm talking. If I'm boring you with the presentation, please dig into the project themselves. I will bring that back at the end of this segment once we have, so you can get back to it if there's something here that you want to find out more about. So these are our 15 projects that have been added over time. They each one participate in one particular aspect or another of motion picture development. And so now I'm going to go into what they do. So OpenVDB is developed by DreamWorks. It won an Academy Technical Achievement Award. I forgot to mention that there is, of course, the Academy Awards that everybody know, but there's also the Science and Technology Council holds a separate event where the technology is given award. You see it at the Academy Award telecast for for a few minutes. They do a summary. And so many of our projects have won Technical Achievement Award in that particular ceremony. Was the first project donated to the Academy Software Foundation, the first project to graduate. It's a library for volumetric transport of volumetric data, simulation, and animated volumes. The key contributors, you can see the list. It was given by DreamWorks, and a lot of others came to it because of the value that it brings. I have I have a video here that I would like to show you. Talking about OpenVDB, NanoVDB, and Neural VDB. Let's have a look.
OpenVDB has grown beyond its Academy Award-winning entertainment use cases into medical imaging, industrial manufacturing and design, scientific computing and visualization, robotics, and machine learning applications. Whereas OpenVDB uses a hierarchical tree structure, Neural VDB introduces neural representations of both values and the underlying tree structure. This dramatically reduces the volume's memory footprint, allowing users to interact with extremely large and complex volumetric datasets in real time, as well as transmit and share them more efficiently. Neural VDB also carries over the GPU acceleration of NanoVDB, which NVIDIA introduced in 2021. While these side-by-side examples look identical, the memory footprint of the Neural VDB representation is up to 100 times smaller. To speed up training by up to 2x, Neural VDB allows the weights of the previous frame to be used for the subsequent frame. Neural VDB also enables temporal coherency, or smooth encoding, by using the network result from the previous frame. This reduces the need for post-production effects like motion blur.
This is part of a longer video. This was produced by NVIDIA, one of our big supporters at the Academy Software Foundation. And so OpenVDB is an example of technology that was developed for the movies. And there's been a lot of those for visualization and for the rendering of photoreal content, which was the goal of the software, many software development in the motion picture industry. It branched out to become used in a lot of other industries. Now, this is the sort of marketing description of OpenVDB. Now, I have a video that was produced by the engineers of OpenVDB as a song. Yeah, so I'm going to play that now.
Divinity. Be the victor you can win if you proclaim with glee. VDB will set you free.
If you're a volume hippie and you love your VDBs, listen to this song and you'll reach divinity. Be the victor you can win if you proclaim with glee. VDB will set you free. Drop a VDB node and a VDB activates. Fill it up with values, you have taken your first step to make your VDBs become one volume again. Run VDB combine or maybe the VDB merge. VDB from polygons to build your SDFs. VDB reshape will plug any hole you have left. VDB rebuild to fix the collision mistakes. And VDB convert to make the polygons again. If you're a volume hippie and you love your VDBs, listen to this song and you'll reach divinity. Be the victor you can win if you proclaim with glee. VDB will set you free. If you think VDB is pointless, you must try this node. VDB convert points will unlock a brave new world. VDB points group selects and points delete removes. If you know VDBX, you can run all the code. If you are into fracturing, we have you covered too. For the VDB fracture will allow you to cut through. VDB to spirits to scatter all your fracture points. The VDB workflow's here to never disappoint. If you're a volume hippie and you love your VDBs, listen to this song and you'll reach divinity. Be the victor you can win if you proclaim with glee. VDB will set you free.
So this video goes on for 6 minutes. So you're welcome to check it out on YouTube. Search for VDB hippie. So I'm sorry if all the details of related. It's sort of an inside job in terms of what VDB is, but it talks about. It's a good way to do documentation. Yeah, and we're thinking about doing it for other projects like this, moving forward. But it shows you the kind of enthusiasm we have for, and our engineers have for the projects. I don't have a video like this for all the projects, but I thought I would show you this one. So continuing on into other projects, so VDB was about volumetric data, and if you got that from the description, if you render a simulation for volume data, it takes a very long time. But if you can bake it, which is what VDB does, into cloud information, then you can manipulate it and pass it on between different applications much, much faster. So that's VDB. OpenColor.io, it's this, now we're moving into the color space. So when you're making movies, of course, the color of everything you do is very important. The color space and what artists actually see while they're into production is essential. So it's very important that different artists on different software don't see different shade of green or colors like that. I'm going to, I think this video here doesn't have sound. I'll do the commentary. So this is an example that shows the layering that happens in motion pictures whenever there's complex shot. So the scenes and the shots in motion picture will have live action element, background plates. It'll have 3D elements. It'll have green screen that'll be worked on. All of these things happen in different software and different workstation. We see it in 3 seconds here, but it's really taking a long time, and different artists work on different parts. So what OpenColor.io provides is a set of tools so to essentially calibrate everything in the pipeline. Not only the screens, of course, we know about screen calibration and color calibration of screens, but the software that are being used to make the movies, every steps of the pipeline. So it provides profiles and the color science for a consistent pipeline. It was developed at Sony Picture Imageworks, joined in 2019, and has also won an Academy Technical Achievement Award. You'll see that as a team. Today, there's all these contributors. One of the things they do that you may be interested into, if you're interested in color science, they started a Color Interrupt Forum to bring the color scientists and the people interested in color of the industry together. That's a forum that meets every 2 weeks. I'll show you how to get to all of our forum, the information about our meetings. You're welcome to join that. And they're working on a new lightweight version to enable browser usage and other benefits. OpenEXR. OpenEXR, how many of you know about OpenEXR? Can I have a show of hand? Yes, a few, that's good, thank you. Appreciate that. OpenEXR is a high dynamic range image format. It was, in fact, it's the grandfather of our open source projects. It was developed by ILM, made open source in 1999, won an Academy Technical Achievement Award, and joined the foundation in 2019. The high dynamic range image processing and transport is what it does. And essentially, when you make a movie and you pass image information between all these different stations, the layers that we've seen, you want to pass them at the highest possible dynamic range and resolution, etc. And that's what OpenEXR does, and maintain the uncompressed value of all the images across the pipeline. It's widely adopted. Currently, the project goal number 1 is to maintain a rock-solid implementation of this library that is used by everybody on every movies everywhere. So it cannot fail. There cannot be new development that break it. And so that's sort of our fortress project that is handled by Carrie Phillips, one of the person in our industry that's been there and caring for the project for a long time. OpenQ. So now we're moving into the massive amount of frames that need to be rendered when you make a movie. Not only you have to render all the frames, you know, a motion picture has generally between 1,500 and 2,000 shots in them. A live action movie, this is all live action. But very often, certainly visual effects movies, all the shots have visual effects in them. And all these shots have layers, as we've seen in some of these videos. And so that is thousands upon thousands of frames that need to be rendered. There's always a long time to render in those frames, no matter how much compute and cloud and everything else goes into overdrive and how much computer gets faster, etc. The people of the motion picture industry always find a way to use all that power, and the rendering is still an hour a frame at the end of the day. So a render manager is very important to manage all of that, and that's what OpenQ is. It was developed at Sony Picture Imageworks as an internal render farm called Q3. With a collaboration with Google Cloud, it was released as open source when it joined the foundation. So it's a fully featured render manager. The contributors of the company that you can see there, so it's like Imageworks, Google, Netflix, Microsoft, Amazon, and it's been used on those movies, Suicide Squad, Kingsman, Jumanji, Hotel Transylvania, The Meg, I like The Meg. Anyone here like The Meg? And Venom, Men in Black, the Angry Bird movie, the Mitchells vs. the Machine, Thor, Love and Thunder, all the Spider-Man movies, and many more. So it's a rock-solid render management system. So if you ever get yourself in a place where you face rendering a lot of images or a lot of tasks, a lot of compute, you can use OpenQ to distribute them on a large number of machines, either on-premise or in the cloud. So this is a short video that shows a bit of the interface of OpenQ and the layering that happens. By the way, this shot also shows VDB in action. You couldn't do a travel like this on a live simulation. So you see the layers, and you see here in the case of the Spider-Verse movies with this kind of style that goes beyond 2D animation and 3D animation, all the layers that need to manage. This on the Jumanji movie shows the live action plates in the background, the added elements in the foreground, the ostriches and whatever happens. And so in a shot like this, many layers need to be rendered separately and then combined. OpenQ does that. Open Timeline I/O is about editorial timeline. So whenever you do a software that is about motion, about video, you have a timeline. And the number of timelines that have been rewritten is staggering. If you look at every software out there, from After Effects and the Avid timeline, and there is every software in the motion picture industry has a timeline. It's about time that there is a library that people could use if they have to build a timeline to include in their software without having to do it themselves again and having yet another timeline. So Open Timeline I/O was created by Pixar, joined in 2019. It's an open source interchange format for editorial timeline for the management of clip information, timing, tracks, transition, metadata. It's currently working on spatial transform to allow editors to share visual composition across editing software. So it's really kind of the common ground of editorial timeline. Open shading language is describing material lights, displacement, and pattern generation. It's a language. It's a de facto standard in the industry for situations where shaders need the renderer to provide information or perform a task from within the shader is what they're working on now. So with the advent of GPU, a lot of the compute that was at the renderer level has moved to the shader level that can reside on the GPU. So open shading language is developing in that direction now. With functions that are supplied by the renderer as LLVM bitcode and potentially compiled directly into the shaders themselves. If you're interested in any of that, please join us. MaterialX, open standard for representing rich materials. We have a few projects around shaders and materials. So this came from ILM. It's representing rich material and look development in computer graphics. It joined in 2021. And these are the contributors. The thing to say about MaterialX is that the team is very actively working with the OpenUSD ecosystem. OpenUSD, how many of you know about USD? Yes, good, that's good. USD is an open source library that is not part of the foundation. It's at Pixar, but it's a very important one that Pixar is keeping for its own good reasons, but we are supporting that effort the best we can. MaterialX is developing as the material component of USD within the foundation. Res manage packages. So when you have this environment where you have lots of different software in a studio that needs to be customized and installed in different workstations, and certain artists require a certain stack of software, Res is there to come to the rescue of the IT folks and to allow essentially to build a package, a setup package for any workstation at any time, and that includes the versioning of different software that needs to be brought to install on machines. So they're currently working on remote package repositories, a cornerstone of their future res install command to build an entire tool chain on the fly. And they're also following closely the VFX reference platform guidelines that I mentioned earlier in the talk. DeepL, now we're moving into content. So there was a lack of content to be able to test software, particularly at vendors that provide software to the motion picture industry. DeepL was created to provide a place where professional content that was done in the motion picture could be shared and used for educational, for academia, and for testing. It's a vendor-neutral hosting platform, and you can find some of the assets here that are in DeepL currently. And they're currently considering the inclusion of interactive 3D web viewer to help grow the library and increase engagement. Raw to ASIS. So there is a project called ASIS, which is one of the projects outside the foundation, but an important one, another one that we support actively because we support the community. Raw to ASIS is a component, or a component of that is there to convert digital camera raw files to containers with image data according to the ASIS, the Academy Color Encoding Specification project that was done by the Science and Technology Council of the Academy. So the key contributors are the Academy themselves and Weta Digital. OpenFX, an API. So when the 2D phase of our motion picture industry got underway in motion picture and also in commercials and short form, there were softwares like Flame and others before that that were doing image processing. And if you wanted, as a third-party vendor, develop a plugin for any one of those, you had to use the API of that particular application. Nothing unexpected there. However, there was, over time, a number of those software that developed, and the third parties had to redevelop their software a number of times on the various APIs for the various applications. OpenFX is a mid-layer there that allows, if you develop for OpenFX, then your plugin will work for all of the various applications. It's a common interface for image-based visual effects, has a lot of supporters, and is in a number of products like Assimilate, Scratch, Filmlight, Baselight, and Flame, etc. And they released a new version in July 2024. That was a project that was quite stable. It had not updated for a number of years before it joined the foundation. But when it joined, it found a number of reasons to update a number of its components, and released just recently. OpenAsset.io. OpenAsset.io is a project that joined in Sandbox at the foundation. So when a project joins, there's essentially 3 stages that it joins at. The first one is Sandbox, which most projects join there. This is the place where a project comes from the wild world outside, and it gets there to be at a minimum cleaned up and make sure that all the licensing and the code is all right until it comes to be adopted. But sometimes there are projects that are I would say, advanced ideas about something that should be done, and OpenAsset.io was that. There had been a prototype and a design that had been done, and they moved to the foundation in Sandbox to develop that idea further. The TAG, the Technical Advisory Council, judged that this was a worthy project to be developed, and they provided the Sandbox environment for them to develop further. It does here what you see was the first project to join the foundation. It's there to make the connection between asset management system and the systems like USD, for instance. The Open Review Initiative. So something happened at the pandemic. At the pandemic time, everybody, before the pandemic, when project, movie, motion pictures were reviewed, they were reviewed in a theater, a small theater, with motion picture grade projectors, motion picture grade sound. This is where, when the visual effects and animation facilities were looking at shots, they would gather people once a day, and they would go and look at all the new shots and make notes and send people to do their work. At the pandemic, all of that stopped, and people ended up at home, like everywhere else, and the review process became done on home computers and screens. So all the quality projection systems went away, and that created a complete redesign of the review systems in the industry. At that time and after, the Open Review Initiative was started to assemble a number of components that could be the base of a next generation open review system. And there was 2 donations to the project. One was RV from Autodesk, commercial software that they worked hard to make open source. It became OpenRV. And X Studio, a review system that was at DNEG, that was also donated to the foundation. Within these 2 projects, the Open Review Initiative now is to building a unified tool set for playback review and approval of motion pictures and related professional media. Autodesk contributed RV, as I said, and DNEG X Studio. They're currently working on establishing a real-time cross-product collaboration for image review, exploring optimized encoding, and decoding of video media. And OpenImageIO. OpenImageIO is a library for reading and writing files. An emphasis on formats and functionality used for professional large-scale film production. It's used extensively in the VFX and animation world, and they're currently working on a set of Rust bindings and Python wheels that will allow PyPI install with single command. Our last one, maybe you're happy, we're at the last project, OpenAPV, just joined, donated by Samsung. OpenAPV is an advanced professional video codec that provides reference implementation of the APV codec. Samsung is coming with their long-standing commitment to open source. Samsung is a company that uses Android for their phone and ties in an open source operating system for their television. They have open source at the core of their operation. And they thought that bringing APV to the foundation would be the right place for them to learn from the community of the motion picture industry what is needed to really bring OpenAPV at the level that they want it to be. So, besides the project, we have a number of working groups, and I'm going to speed up because time is running out. A CI working group, I've already mentioned it. A diversity and inclusion working group that is doing excellent work. A USD working group where the community for USD that resides at Pixar comes to talk about USD. And a language interrupt project. The DI working group is doing every year a summer learning program, amongst other things, that prepares individuals from underrepresented community to get a job in film and media and entertainment. On the right side there is an example of what the graduates of the summer learning program, the jobs that they got inside the industry. You can keep an eye on that. And the CI working group is working on the 2025, aligning with the 2025 VFX reference platform. And the USD working group has a Slack channel with more than 1,000 participants, part of the vibrant community around USD. And we have a new Zero Trust working group ramping up activities. This is over time, the PR that were open each year for all of our projects. As you can see, it goes before the foundation of the foundation of our Academy Software Foundation, because the project existed then. You can see that in 2019 there was a big spike and has been sustained ever since. The cumulative open issues each year, we see the growth there. And that was our project. Now again, here's the QR code that was there before. So if you want to go into more details on any of the project, don't hesitate. And we also do events. We have a conference called Open Source Days that comes at SIGGRAPH. We also have the Open Source Forum that is happening in February, very soon, that is more of a member-oriented conference. You can find on our YouTube channel the recording of all the presentations that we've done at our conferences, the most recent one being Open Source Days in Denver, and we have a whole number of presentations, including full updates on the projects that you can go see if any of them interest you. We just started a new conference or a new event called Dev Days, where there was the second year. The first year was a bootstrap effort. Dev Days is really a hackathon. It's a way to come in for people who have not contributed to any of our project yet to do their first contribution and to get familiar with the environment and where all of our projects are, or the participating projects are ready to support newcomers. We are very welcoming environment, so this will happen. We're right into the debriefing of Dev Days that was set as an annual event. It will, for sure, will be in the spring, and we're looking at making it a more of a continuous event as opposed to a one-time-a-year event, so that we have all the tools and the ability to welcome developers who are interested in contributing into projects from the motion picture industry. So how to contribute? I'm not going to read all of that, but you can go into that link at the bottom, tac.aswf.io/engagement. You will be able to join our list. You can join our Slack channel. I'll have that on the next slide. These are our mailing list. And if you want to join our Slack channel, this is the QR code to grab. It's going to be valid only for a week. So if you have any interest to come in, please don't hesitate. And I want to thank you for having me and staying for the overview about the Academy Software Foundation. Thank you. I'm looking forward to be here at the Ubuntu Summit with you and getting to know you. And don't hesitate if you want to join us or to come and work with us. We'd be glad to have you participate in our movie-making activities. Thank you very much. I'm not sure if we have time for questions. Do we? Any questions from the audience? Yes, please.
I'm here with my technical author colleagues, so I think we're all a bit intrigued about your novel paradigm for documentation that you mentioned earlier.
That's good.
I also wanted to ask about something that was mentioned very, very briefly in one of the videos, that the software that was developed for the motion picture industry is being used in medical research.
Yes. Mm-hmm.
And it just went by very quickly, but can you say anything more about that or other examples of unexpected usages of things that you're producing here?
Oh, yes. So it's actually a big trend, and it has been one about software developed from the motion picture industry, that it's been reused in all the other industries after that, because the engineers of the motion picture industry, when computer became a thing, computer graphics, had to aim at developing photoreal imagery that match the live action footage, right? So a lot of the algorithms for rendering photoreal anything, photoreal glass, photoreal, car, paint, photoreal human flesh, to animate characters. Jurassic Park was the first time ever that there was a computer-animated creature. All those technologies, and the motion picture industry is a very open industry by nature. At SIGGRAPH every year, the studio go to present the algorithms that they've been using openly, and so those have been picked up all over. And it's fair to say that a big part of the visualization industry in the world, the base algorithm have been developed in the motion picture industry to start with. So that's something that is a major trend. If you're looking at particular software that are being used in other industry today, so OpenVDB is one. I mentioned USD a number of times, Universal Scene Description. So there's a big push at the moment to take USD, which is the back-end data management system that Pixar used to do all of their movies, a very sophisticated system. Now there's been a lot of discussion about using USD for VR applications in gaming, for using USD in the car industry, for using it into all of those other industries that have huge database of content, and that require, in this specific case, the ability to make modification and remember what you modified. When you make a movie, there's notes, there's all kinds of things that accumulates over time, and sometimes the director will say, you have to go back from the version for 2 weeks ago, and you have to be able to do that instantly, to undo all the things that have been done since 2 weeks and go back to that version that the director liked at that time. So USD is able to do that, and as it turns out, that happens in all industries, that you have a big database of representation of a building or a car, and you want to track all of the details. So that's another example, but often the algorithms have been used in many places. Yep.
Thank you.
You're welcome, please. Yeah, thank you.
So 2 quick comments and then a question.
Okay.
One, thank you very much for the reference platform, the VFX reference platform. As a student, you know, seeing what actually is used in industry, you know, when I was studying computer graphics, I could look at tools and be like, oh, that's a thing that's worth looking at. That was great.
You're welcome. I will pass your thank you to the visual effects technical committee.
And a big thank you especially to the OpenVDB. Like, I switched to using that, and it was, their marching cubes was like 30 times faster than the random file that I'd been using before for that. So that was
Good.
great too.
I'm glad it works.
My question is there a good open alternative to VBX? Or, sorry, not VBX, FBX?
FBX. So FBX has done, you know, a good job in the industry for a long time, and there's a consensus, including from Autodesk, who is the owner of FBX, that now the next generation will be through USD. Yeah, the USD and the OpenUSD. The work that's being done right now to essentially by Pixar and others to take USD as it is at Pixar and make it open and develop a lot of tools around it. There's actually a foundation, the Alliance for OpenUSD, if you're interested in that you should track. It's a sister foundation from our Academy Software Foundation, and they focus only on USD, making it a specification so that other industries, as the previous question was, so that other industries can use USD not just in software, but also in hardware, in compute, and implement USD. So a much more flexible system at large than FBX was. FBX is great. FBX is a great tool to essentially bake a scene and pass it on between a software and another. It does what it does very well. But if you're talking about massive, production level database, USD is going to be it.
So that can also scale down as well, though, to the smaller?
Yes, there is also all kind of tools in USD. There is a sub component of USD like USDZ, USDC that are packaging of USD components. So have a look. It's extremely flexible, but it's also able to carry data on phones and on compute that has less resources than the motion picture studio. Yeah.
Thank you.
You're welcome. Thank you. Thank you.
Thank you so much, David. Afternoon break, right? So I think many of you have been sitting down for a while. If you have any smartwatches, they're probably telling you it's time to move around. So really quickly, if you don't know where the afternoon break and refreshments are, just exit as you would. It's actually everywhere, very open concept. The next session will start in 30 minutes after that, so please join us at 4:30 p.m. Thank you and bon appetit. To everyone online, take a break, grab a coffee, or grab some tea. Welcome back, everyone. Day one of Ubuntu Summit 2024. We've actually had an update that we are above capacity for all the in-person registrations. So while everyone streams in from the afternoon break, we've actually started notifying people through our social media channels that they can only register remotely to watch the live stream. So everyone that is here, thank you so much. Our next speaker is an open source strategist and director of sales, and co-founded the Linux Foundation, Community Health Analytics open source software project, an industry forum of experts that develops the best practices for measuring community health. Please welcome to the stage George Link.
Hello.
And Luis Canas Diaz from Liturgia.
Thank you, Ahmed.
Thank you.
Hello, everyone. Welcome. I'm happy to be here with you today on this Friday afternoon. The question that we want to address, or the dilemma we want to address, is around the software supply chain. When we build software, we have a dilemma of choosing the open source projects and maintaining them. And we know that with more than 7 million open source components published in the last 12 months, and only about 10% of those being actively used, there is this vast noise of unused open source components. And we also know only a fraction of those are being maintained and actively developed. So this creates an opportunity for malicious actors. And we know this is actively happening. Over the last years, there has been an increase in malicious packages being discovered. And we also know businesses that have been affected by software supply chain attacks today spend $50 billion. In 2023, that is expected to increase to 138 billion. And if you think this is only affecting some companies, think again. Gartner is expecting by next year that 45% of businesses will have been affected by an attack. So now that we know the chance of being attacked, what is the impact? When it comes down to money, what are we talking about? From the SolarWinds example, we know that businesses affected by this spend on average 11% of their annual revenue. So if we take 45%, flip of a coin being affected, 11% attack impact, we're landing at about 5% of annual revenue that we are losing to software supply chain attacks. So this is a big problem that we need to address, and that is what we want to talk about. Luis?
Hello, thank you. My name is Luis. I'm passionate about open source and also about data. I've been working with open source for the last 22 years, and I've been providing insights based on data, based on open source projects and communities for the last 12 years. I'm also a Chaos contributor. Chaos is a project by the Linux Foundation. It means it stands for Community Health Analytics and for the open source ecosystem for open source software.
Thank you, Luis. Luis is on a mission to help open source projects make a big impact and create a better world. I am Georg Link. I'm an open source strategist. I have more of a business focused. My mission is to improve the health and sustainability of open source projects. I've been in open source for more than 20 years, both on code contributions and non-code contributions. I co-founded the Chaos project, which looks at community health analytics, and built that community. So that's who we are and why we are here today. So let's take a step back and identify where does the problem lie. And I want to start out by this metaphor that software ages like milk, not wine. Wine gets better the older it gets. Milk is best served fresh and then becomes spoiled pretty fast. And in software, similarly, it becomes outdated. We discover vulnerabilities, and it generally ages pretty quickly. Now, if you have milk in many dairy products, we have labels that say used by, and we know that if the supplier, a farm, had spoiled milk, we can trace back into what products it was used in. And we have that same thing in software where we maybe not have an expiration label yet, but we have the software supply chain concept. And I'm going to ask Louis to share a little bit what the context is.
I love talking about wine, but let's use this example to see what is happening in the industry. Depending on the reports you see, there are very well-known reports lately. From 87 to 90-something% of the current produced components in the industry contain open source software. So everyone is using it. The big success of open source is that everyone needs and uses open source. So what is the risk here? Big corporations, they tend to grow very quickly components because they use open source. And for small teams, they can think that they know the dependencies they have. But if we think about the dependencies, not only the first-level dependencies, but the dependencies of the dependencies, then things start getting more and more complex. So this is what we call the unknown risk. Big teams, small teams also, but big teams, they basically don't know about the software they are using. So they have no idea. They may know the license, but there are many, many different topics and points of view that are totally out of the scope. If we focus on some example component, most of the components today, and this is again from another report, they have like 200 dependencies if we think about the whole tree. Not only the first-level dependencies that are declared in the code, but the dependencies of those dependencies. This is called the dependency tree. If we think about the dependency tree, there are three ways. There are three approaches that you can use to trust these open source libraries your component is using. The first one is to study the license. The second one is to study the vulnerabilities. This means the security errors reported. And the third one is to support the projects or dependencies that are not well maintained. But this is not easy. So for licenses, there are many well-known tools that provide you a list of the licenses for each of the components. So in your company, I guess that you have a list of licenses that you want to avoid. For instance, some companies, they don't like the GPL, so they want to avoid at any cost using GPL. Of course, you will have to avoid the incompatible licenses. This is already solved by many different tools outside. The second set of tools, they give you a list of all the vulnerabilities that your components have. For each version, they tell you the number of open vulnerabilities, so you are aware of the issues of the current code you are using. This is already solved. For the third one, we start entering the gray zone. There are some companies, that are supporting projects that are not well maintained, so they provide you a package with a component and the subcomponents, and they take care of everything to make sure that they are maintained. What we miss here is that in the 21st century, modern software companies should make informed, data-driven decisions about the software they're using, and they are not doing it. We think that they should be able to make informed decisions to choose the well-maintained software, and this is not happening. This is happening with licenses. This is happening with vulnerabilities. This is not happening with well-maintained projects.
So we have some maturity here that we need to climb the ladder. And for this, we we're conceptualizing a risk assessment model, focusing really on that community risk. And I'll drive home the point again that what we're talking about. So if you imagine a car, you're driving your car, low fuel comes on. What do? You go to the gas station, fuel up, you continue. The engine warning lighting comes on. You go to the shop, get it repaired. That works as long as your car is being maintained. And this is what we have with licenses and vulnerabilities. We know what is the state today. We know how to fix that. When we look at a car that is an old-timer, then you end up in a situation where you cannot get parts anymore. You go to the junkyard, and you have to find a mechanic that is still dealing with old cars. In software, that is where we have under-maintained projects. So that is the problem space we're in. And looking at under-maintained projects, we were considering 3 factors for what that could mean. One is, can the community handle the workload? And we used the metrics Backlog Management Index and Review Efficiency Index. Second, can the community address the workload quickly? We were looking at lead time for issues and pull requests. And third, does the community have the right talent or inflow of talent? So how long are contributors staying in the project? Is the community of active contributors growing? And what is the contributor absence factor, also bus factor, or we called it pony factor? We took these metrics and normalized them, aggregated them into one score for each component, for each library that we had, and then combined those. So if we have 180 different packages in our component, then we aggregated those scores together. I want to show you what that can look like. And this is a prototype. So this is something we're actively thinking about how to improve. This is the dashboard, and we'll walk through different components. One, we can filter into specific software components that we're interested in. Here we looked at Kubernetes Golang dependencies. We have on the right a set of indicators, like traffic light, green, yellow, red, low, medium, high risk, and we can see how many of our dependencies land in each category. We also had very high risk. Those were the projects that did not have enough activity for us to calculate some of the metrics. And then we can map this in a heat map where we can start to see where the different dependencies land. On one thing here that stands out, the pony factor, the third row from the bottom, there's a lot of high risk. Lots of the dependencies here only have one main core developer. And then we can drill down into the components themselves to see, okay, this one, I just picked a random one, it has a medium risk. Why is that? How does that come to be? So we can look at the individual metrics, and you see the numbers on the right side, and we have thresholds to say this is low, medium, high. And in our experience, everyone has their own thresholds. So this is something that can be configured. And in this case, the high risk comes from the lead time. So now that we know this, we can decide what do we do with this dependency. If we want to continue using it, maybe we can go help the project address the issues and pull requests faster. Or we sponsor a maintainer to do that. Or whatever solution we want to drive forward, knowing where the problem is helps us get there. So that is the risk mindset and how we can get there. And we used an open source tool to get the data, and I'll let Louis introduce that.
All the data you saw in that prototype is collected, enriched, and produced by GrimoireLab. GrimoireLab is the project we collaborate with. It is part of the Chaos project, which is part of the Chaos Foundation. A little bit about the history. When I started working for a research group in Madrid, the former and current colleagues there were working on research reports, on research analysis. And many of them were created their own ad hoc scripts to get data, to publish, to make publications, basically. So the idea was to create a set of tools that was used by the scientific community to create a big data set that could be used and validated by the different projects. So with that idea, we created several scientific publications, and in 2012, some of us created the company, Vitergia, and in 2016, we moved from the old tools to GrimoireLab, which is the revamped version of the old one, which was named Metrics Grimoire. We switched from Metrics Grimoire to GrimoireLab. We started using the Elasticsearch stack. Some years ago, we moved to OpenSearch because we want to stay open source. And in 2017, we joined Chaos. We contributed the code to Chaos. And this year, we released the version 1.0. We are very happy about that. And currently, we are working on the version 2.x with the main goal to scale up, to analyze a really big amount of projects. This is an example of the reports we created lately. This is a bit old, from 2020. It is called, I love the name, it is called Mozilla and the Rebel Alliance. We created this report with Mozillians and with another company. We obtained all the data with GrimoireLab, and we also got the insights that are included in this report. So I recommend you that you have a visit, that you have a look. The main goal of the report was to show the activity of the status of the community, but also the impact of the Mozillians in the open source ecosystem. And those are other examples of different places using GrimoireLab. For instance, OSS Compass, it's supported by several Chinese companies. They provide metrics from data obtained from GT. GT is like the Chinese GitHub. LFX, the Linux Foundation Insights, the first versions of the tool were using also GrimoireLab. And we, Vitergia, we are using GrimoireLab for a service we call Vitergia Analytics Platform.
So how does the process work? When we collect data, we collect digital footprints, the Git log, the issues, the pull requests, comments opened, mailing list, emails. Basically, we have 30 different data sources that can be collected to see the activity of the community. We're aware that there's a bias to what can be collected, and not everything in an open source community is captured in a digital footprint. Then we have the enrichment phase, where because we have so many different tools we're collecting data from, it needs to be normalized and made useful. And then finally, visualizing and reporting so that we can tell the stories or build the risk model that we were showing earlier. One of the key components is an identity merger, where a contributor like me, I have many different email addresses. I have different usernames across different platforms. I have been working at different companies. If that is something we want to know, who are the companies in our project? This is something the tool has solved as one of the key challenges. And I also want to be mindful when we talk about personal identifiable information that this needs to be protected, and we need to be mindful about collecting and processing this data. So we have been working with lawyers to make sure we comply with the GDPR, looking at, can we do opt-in or do we have to do opt-out, which typically in an open source community, everyone contributing knows we are contributing to the public and the contribution will be known. And having analysis on the community tends to be for the good of the community, especially when we do this as a community dashboard. And so there are some things, I don't want to get into all the nitty-gritty details, just as a primer to also think about this when using a tool like GrimoireLab. There's a whole architecture from collecting data. I love the names that you decided on for the components, like Percival, the loyal knight that goes out to look for the Holy Grail, or King Arthur that is overseeing the whole process. And the roadmap, there are 3 key things we are working on right now. One is the maintenance effort is high. We want to get that down. have more user interface or APIs to automate things. Scalability, right now it takes a long time to collect data and process it. Parallelizing that, we need to change the architecture, and also providing data into other tools through APIs and allowing users to visualize it and analyze it in different ways. Especially with artificial intelligence, you need high quality data and make it available in different formats. So that's what we are working on. There, you're welcome to get started. The tutorial is a great place to start working with the open source version. If you prefer to just work with the tool and get the data, you can also get Bitergia Analytics as a commercial supported version. If you only take away one thing from the talk today, I want to leave you with this thought. We need to understand the risk in our software supply chains. After licenses on vulnerabilities, the focus needs to broaden to include community health. And we have a tool in open source, the GrimoireLab tool, that is the de facto industry standard that can help you get started on that journey. With that, thank you. We are welcome to take any questions.
Thank you very much. You've talked about the work that you've done to pull a picture of health out of all these multiple layers of dependencies. And it's a lot of work for you. For example, the disambiguating a user's name. And I wonder if there's an opportunity to do things also from the other direction so that people or projects can push information upwards. You know, you can go on GitHub and you can get an instant picture of open pull requests, open issues, and so on. But if there were a systematic way for such projects to project other data about themselves, more not just about pull requests, but that gave you those kind of metrics that you're working hard to pull out, would that be of value? Would it even be possible?
Yes, I have some thoughts in the Chaos project. We are talking about how projects can do that and how they can signal their health in different areas through badging, through having files that have that information. I also know the Cyclone DX community is thinking about how to integrate some of that information into the SBOM that the Cyclone DX standard supports. Do you have other thoughts, Luis?
No, I was thinking that for most of the open source ecosystems, it is very relevant to be neutral for foundations, for instance. So if they public the data and the metrics for at least something that is beneficial, not only for the ones producing the software, but also for the ones consuming the software. So I think it's an interesting idea.
Thank you for the question. We're at time. We're happy to connect with you after the talk as well. Thank you so much.
Thank you so much.
Thank you.
Our next speaker is the co-founder and project lead of Matrix. His day job is CEO and CTO at Element, the company founded by the team who created Matrix to support their development work. Please welcome to the stage Matthew Hodgson.
Thanks. Hi, everybody. Can you hear me? Yes? No? Yes, brilliant. Wonderful. I apologize that I'm the one person standing between you and the drinks, so I will endeavor not to go on for very long. Welcome to Matrix. So I'm Matthew. I'm the project lead and co-founder for Matrix. I'm also CEO and CTO at Element. Who here knows what Matrix is already? Okay, that is a reassuringly large number of people. I guess it may be something to do with the coordination for the summit happening over Matrix, as well as the fact that Matrix has now been around for a little while. But just to recap it from my perspective, if nothing else, the idea of Matrix is that it is this open standard and open protocol for secure, decentralized real-time comms. Now, you're probably familiar with using it for chat. However, you may not be familiar that you can use it for one-to-one and group VoIP. You could also use it as a general-purpose data fabric for any kinds of real-time structured data, so publishing and subscribing with end-to-end encryption of anything. It could be Internet of Things data, it could be, I don't know, telemetry of drones, it could be geospatial data. You can even use it as a communication layer for VR and AR. However, most people use it for chat. And the mission of Matrix is really to build the missing real-time communication layer of the open web. So, when Tim Berners-Lee came up with the web in the first place, it was very much intended to be this amazing dynamic read-write environment. In fact, I was checking out the code to the original web browser, written, of course, for NextStep the other day, and was shocked that even from the outset, you had an authoring component built in there. So you could both read the web pages and you could author HTML. However, my theory is that HTML got way too popular too early, and people started blatting out GeoCities sites and creating crazy web apps on HTML, and so the kind of interactive, real-time interaction got forgotten. Now, nowadays we have ActivityPub, looking at the kind of microblogging, social web use cases, but for the real-time instant messaging and VoIP with privacy, Matrix is still the main place where this is happening. So the idea of Matrix is that no single party should ever own your conversations. There should not be possible to have a Facebook or a Google or some other big sort of information silo who goes and sucks up all of your conversations and controls it. Instead, everybody should be able to run their own server in a big, open, public federation, a bit like email. However, better than email, conversations get replicated over all participants. So again, you can't end up with a Gmail-style situation where everybody just gloms onto that server, because the second that anybody spins up their own server, they will keep a replica of all of those conversations themselves that they participate in. So architecturally, it looks like this. You've got a mesh of servers replicating these conversations together, and then you have Matrix clients in green that connect through to these servers. You then have the concept of application services, which allow you to basically build out additional functionality on Matrix. And the typical thing that people do is to build bridges to other systems. Now, I hasten to say that bridges are always a compromise. There is always an impedance mismatch between IRC or XMPP or Discord, Slack, WhatsApp, whatever, into each other, and also into Matrix as a kind of common language. But some people do use it, like I saw that the Hash Summit on Ubuntu.com room is bridge free to Telegram, using a bridge run on a completely different server to the Ubuntu.com one, I believe. And people can also bridge on to IRC or other systems too. Now, a diagram you might not have seen is the way that Matrix sometimes gets deployed outside the internet. So on the right-hand side, we have this slightly opaque blob of the internet, but often, particularly in the last few years, we're seeing more and more deployments of Matrix in big private federations for people like NATO, or, I don't know, the French government, or the German government, who go and spin up lots and lots of servers in different ministries and departments which interoperate with one another. And then they might have links through to, say, higher classification networks for operating at secret or top secret, which go and connect through what are called cross-domain gateways, which are these crazy hardware appliances that go and basically check the information that is going back and forth between these private federations. And you can also have a border gateway that goes and connects your private federation through into the public internet. And the reason I mention this is that the world of Matrix is currently split into slightly random ways, half of it being a whole bunch of open source enthusiasts, such as ourselves, going and using it as a modern version of IRC, and then also a lot of people in the public sector, in governments, using it as a secure way for different governments and organizations to communicate with what they call digital sovereignty, i.e. the ability to run all of their comms themselves. I'll talk a bit more about it later. In terms of Matrix's vital stats, right now we are at around 170 million federated known users ever. Now this does include people who have never come back, so it's very much a high sort of estimate of the total number of Matrix IDs ever, but it is what you get if you select staff from users on every Matrix database that reports back to the Matrix.org Foundation on its usability stats. And then in terms of monthly active users, which is a bit more of a useful metric, you can see that over the last couple of years, we've gone up from around 1 million monthly active users to at the moment around 4.5. It's dipped a bit over the summer, but is starting to come back now. And you can see there is a kind of sawtooth pattern as the calendar year progresses over the years, and currently growing relatively linearly. So, another quick silly metric on Matrix is that Stack Overflow goes and runs a survey every year to ask what tools people like. You know, what's the most favorite Linux distribution? What's the best programming language? And what is the most admired synchronous communication tool? And we were fairly chuffed to see that we are, as Matrix, the most admired communication tool, just edging out Discord and Signal by about 0.3%. However, we, in terms of desired, in practice, I guess we're second to Signal in terms of open source desired ones, but a lot of people, in terms of what they actually want to be using right now, end up saying, hey, Slack, Discord, and Teams is where it's at. So architecturally, how does Matrix work? The way the Matrix works is that your chat rooms are what we call directed acyclic graphs of information, that they're made up of events like Matthew joins a room, Matthew sends a message, Matthew kicks somebody out, Matthew sends a file, and all this sort of thing. And in practice, they're very similar to a Git repository. And I'm sure that everybody here is familiar with Git and how it works as basically a graph of commits. Well, in Matrix, each room is effectively a repository, and each message is effectively a commit going and showing the various people across the various servers going and pushing and pulling those commits from one another. I have a vaguely pretty diagram here, which I will try to scroll into. Sorry for the crappy resolution. And you can see what happens is that if Alice is on alice.com, then to send a message, that's literally the code that she might send in order to say hello as an m.text type of message to that URL on her server. And so it is a one HTTP post, and she gets back an event ID. That server then starts building up this directed acyclic graph data structure, persists it in the server, and pushes it out to the other servers in the room. And here, the HTTP request is a bit more ugly because it's got some signatures from her server on it, as well as a few other bits of metadata that have crept in. If we then hit next again, then you can see that it gets sent out to Bob and Charlie.com and their respective servers. And what happens is that Bob and Charlie just poll on the /sync endpoint, and it blocks until there is a message to be received, and then they receive it. And you can see I'm a fish, or whatever the message is, and again, the m.text type and the extensible event type there as well. So that's basically what happens as Matrix operates. And what we can see here is that Bob might send a response, which starts to build out a more complicated data structure. And say if Charlie also sends a message at the same time, then the three servers are out of sync. Oh no, it's disaster. It's like 3 Git repositories where some people haven't pushed all of their commits yet. And all that happens is that subsequently, Bob will send out his message to Alice and Charlie, and Charlie will send out his message to Alice and Bob. And you can see at this point, the 3 servers have got roughly the same data structure developing inside it. So that's all the Matrix is doing. It's basically replicating graphs of data across a set of servers whilst going and implementing access control to make sure that people get kicked, and they get given power levels and made operators, or invited and parted, and all the other semantics that you would expect. And in fact, it turns out that the main academic novelty of Matrix is that it does provide this decentralized access control. I'll talk a bit about it in a minute. Where have my slides gone? There they are. So, as I said, state resolution is actually the sort of academic novelty. And here is a sort of real graph, and you can see that somebody creates a chat room, Alice joins it, she sets up the access controls, she might say who's allowed to join it, she invites Bob, she invites Carol, and then Bob joins. And what we actually have are two graphs showing how these events link together. And one of them, the black arrows, is just the causality of what happened next. And this is allowed to split and reform, as we saw in the previous animation. But we also have the red arrows, which are what we call the authentication DAG. And this is the important, semantically important state events, things like people getting kicked or joined, etc. And what you do in Matrix as a server is that every time you send a message, you include a proof. You include what we call the auth chain to say, Bob is allowed to join because he was invited, and the room allowed him to be invited, and that room rule was set by Alice, and Alice created the room. So every time you do anything, you basically prove why you can do it. All the other servers execute the same proof. If they agree that you're not breaking the rules, then they allow the thing to happen. If you are breaking the rules, then they will just reject it. So it's a form of consensus algorithm, albeit without any blockchain stuff or anything. Again, it's much more similar to Git than anything. But it's kind of nice because it means that you can set up these access controls without there being any central metadata or arbiter of what's going on. Practically speaking, client-server API, as I said, HTTP post to send a message. To receive a message, HTTP GET on /sync that blocks until there's something to see. Server to server, much more complicated and ugly, and I won't bore you with it, but it does contain basically the pointers of both the auth chain, the red arrows, as well as the previous events, the black arrows, as well as signatures. Now, Matrix itself grows via an open governance process called the Matrix spec process. It is fairly ripped off the Rust governance process, where people make proposals of how the thing should evolve, and you do this by just opening a PR against a single monolithic spec. And then if people think this is a good idea, they propose it for being merged, or perhaps if they think it's a bad idea, they propose that it gets closed. And people on the spec core team, which is a team of 11 people, 10 people, at the moment, go and put checkboxes on the GitHub PR to say whether they think this is a good idea, and then it gets merged into the spec itself. So this is very different to, say, a IETF RFC process, or say an XMPP, XSF, XCP process, where you have lots and lots of different RFCs, or lots of different ZEPs. Instead, in Matrix, you basically have one spec, which is currently on Matrix 1.12 as of last week, I believe. And then people update it with PRs. So it feels more like one homogeneous project that is growing over the years. And you can see, at least until I last generated this graph, that it grows in a suspiciously linear fashion with new MSCs coming in, a bunch of them getting closed, and a bunch of them getting merged, and roughly twice as many coming in as are getting solved, as is often the case on these projects. In terms of the life cycle, again, I won't go into massive detail, but it's kind of fun in that anybody can just sketch out a proto-matrix spec change. There isn't a formal template or anything. They can then turn it into a real matrix spec change. Again, there isn't really a formal template. It's free-form markdown to say, hey, I think that matrix should allow you to, I don't know, define bands based on whether people's names contain a particular letter or something like that. You would say how you think it's going to work. Then people will pile on to go and review it and explain, we already have this much more generic MSC that allows you to ban people based on regex, and so on and so forth. And then it basically goes all the way through until eventually it gets released in the next quarterly release of Matrix. And we have some fun games about vendor prefixing. Anybody from the web will be familiar with the nightmare of what do you do when you introduce new HTML tags or new CSS attributes and directives. We have the same drama in Matrix, but these days we have it just about under control. If anybody cares about a comparison with XMPP, it's worth noting that Matrix is a completely diametrically opposite philosophy and architecture in almost all ways. And the history of the Matrix team is that we did start off building XMPP-based chat apps about 10 or 13 years ago or so, and got a bit frustrated by some of the limitations that we experienced at the time. And so we created Matrix as this thought experiment of what would it look like if you built it with web technologies, making very different decisions along the way. So you have a single monolithic consistent spec. You have completely different primitives. Matrix is all about replicating conversation history. It is not message passing or pub/sub. Group conversation is a first-class citizen. You don't really have DMs in Matrix. Instead, you have chat rooms with 2 people in them. There is no special concept of direct messaging anybody, which is very convenient if you have multiple devices or if you want to, I don't know, include a bot or an assistant into a conversation. End-to-end encrypted as a first-class citizen because, let's face it, if Matrix is replicating all of your conversations between every server that participates in that conversation, that could be a lot of people. Now, if we just dip into, say, the Ubuntu Summit room right now, which I have hopefully here, and we go and open up DevTools in my Element web, you can view the servers in the room, and you can see that we've got, well, probably at least 20 or 30 in there. 123 on matrix.org right now, but 41 on ubuntu.com, as you'd expect, 2 on kde.org, 2 on mozilla.org, 1 on element.io, 36 bridge from Telegram on t2bot.io, etc. So if this room was end-to-end encrypted, you would be splatting the JSON of all of these messages over all of these different rooms. Sorry, shall I change the theme on this to make it a bit more legible? Bling! There we go. Sorry if that was not legible enough. And so yeah, I mean, if we just pick one of these messages, like I think I saw it near the entrance, you can always view source in Matrix. Again, it's like the web, and you can see under the hood, we've got the JSON of this body and this message type. You can see the timestamp it was sent, the sender who I'm picking on, apologies, the type of the message here. But it could be a lot more exciting thing. Let's find a more exciting message in the scroll back, like a picture. Let's go and look at this one. Much more fun. We've got the file name here. We've got its metadata, like its width and its height. How many bytes is it? What's its MIME type? We can see the underlying binary blob URL, which again is replicated over Matrix. If this room was encrypted, then there would also be the initialization vector and the key of the AES-256 keys needed to decrypt the binary blob. But my point is that if this wasn't a public room, which is being indexed by Google and things, and it was private, then obviously you need to have end-to-end encryption in there. Right. So finally, as a comparison with XMPP, we're using HTTP and JSON as the baseline API. Super important to understand that Matrix is not just HTTP and JSON. It can very much use other more efficient transports. We have CoAP and CBOR-based low bandwidth Matrix, which is about a 65 times improvement in bandwidth over dear old HTTP and JSON. There are various other low bandwidth Matrix dialects as well. And also, in the end, we called it Matrix because it is about defragmenting and bridging and linking together existing silos rather than necessarily trying to be a new network in its own right. So this is what the ecosystem looks like these days. You've got the Matrix spec as the kind of holy of holies in the middle. I just explained how it evolved via Matrix spec changes. Then we have various servers at the bottom. We have Synapse, which is the original Python and twisted implementation of Matrix. We have Dendrite, which is an experimental Golang implementation. There are then lots of bridges and bots and services to other platforms. And then in purple, we have stuff that the wider Matrix community does. So there is the Conduit Rust Matrix server. There is also the Conduit fork of that. There is another fork of Conduit called Grapevine. There's eJabberD, the Erlang XMPP server that also supports Matrix now. There is an Elixir implementation called Polyjuice. There's a C++ one called Construct, and so on. And again, lots of other bridges, bots, and integrations too. And then on the client side, we have, and by the way, the green stuff is stuff which is published by the Matrix Foundation, although Dendrite should actually no longer be green, and I'll talk about that in a bit. So you have SDKs for the web on JavaScript and React. You then have the old legacy SDKs in Swift and Objective-C for iOS, and Kotlin and Java for Android. And we have what we call our sort of first generation apps, Element Web, Element iOS, and Android, as written by Element as a kind of flagship app on top of the foundation SDKs. We also have Element Cool as a new VoIP conferencing system that I'll talk about. Then we have Hydrogen, which is, as you can see, grayed out. So unfortunately, Hydrogen has suffered from funding woes over the last couple of years and is currently on hiatus. This is a progressive web app toolkit for Matrix clients. So very, very small code base. It's about 70K of HTML and CSS and JavaScript. It has no dependencies at all. It is written in that well-known vanilla JS framework. And then on top of it, you have Hydrogen itself as a demo app. And we also built Third Room, which is an entire metaverse, spatial and compute environment on top of this too. Then, the most relevant things, Element X on iOS and Android are the latest generation apps from Element, which are built on top of the Matrix Foundation's Matrix Rust SDK. So this is the way of the future, where we've basically got rid of the old Swift and Kotlin specific stacks on mobile, and instead written an entirely new one in Rust using a new end-to-end encryption implementation called the Dozomats, and a new crate called Rust SDK Crypto that sits around it, which has been super important in terms of improving the reliability of Matrix's encryption. And then again, loads and loads of other clients out there. There is Fractal for GNOME, there's Quaternion and Qt, there's NeoChat, there's Neko, even Mozilla Thunderbird has Matrix built into it alongside SMTP these days. So, brief history, just to give you an idea of how we ended up here. The team working on this has actually been together for a hilariously long time, since 2003. We started off doing phone network APIs. That company got acquired by a telco vendor in 2010. After a few years working in the telco industry, we decided that perhaps it would be a good idea to see if we could build an alternative to the phone network, but on the internet. And then in 2014, so it is not just Ubuntu's birthday, but also Matrix's this year, and that 10 years ago, almost to the week, we launched Matrix. Started to do end-to-end encryption, created Element as a flagship client in 2016. The core team then set up Element as a company to try to keep the lights on in 2017. But then in 2019, we launched Matrix 1.0 and set up the Matrix.org Foundation as a non-profit vehicle to look after the protocol on behalf of everybody. We finally turned on encryption by default in 2020, and then over the last few years, we've been busy working on Matrix 2.0, which is what this talk is all about, and which is what we launched a few weeks ago at the Matrix conference in Berlin. So, the whole philosophy here was, first of all, we'd make it work, and that was what the original launch was back in 2014. Then we made it work right and got it out of beta, which was Matrix 1.0 in 2019. But nowadays, the emphasis is very much on make it work fast, make it work beautifully, make it outperform the mainstream alternatives. So some of the things wrong with original Matrix 1.0, which may be familiar to anybody who has used it over the last 5 years, is that it can be slow, particularly if you're on a sort of a power user and you're in tens or hundreds of, or even thousands of rooms. I'm in about 8,000 conversations, so I get a particularly bad experience. Login can be awfully slow. Like on my account, it's 25 minutes on Matrix 1.0, which is ridiculous. Slow launch too. To just launch a Matrix client on Matrix 1.0, again on my account, is typically about 1.5 minutes. Slow sync. I don't know if anybody has experienced the joy of not using a Matrix client for a week or two, and then going back, opening it, and discovering that it takes 10 minutes to go and synchronize everything that was happening whilst you were gone. Also, slow room joins. You can go and set up a new Raspberry Pi somewhere and go and try to join a big room with 100,000 people in it, spanning 10,000 servers, and it will literally take 3 hours and gigabytes upon gigabytes of RAM. Then other problems. Authentication. We had no 2FA. There was very clunky custom authentication built into the protocol, but not using an existing auth standard. We had basic VoIP for one-to-one calls, and we embedded Jitsi as a quick hack to get group conferencing in, but we didn't have any end-to-end encryption and no native matrix calling. Then finally, and literally to the point of becoming an internet meme, encryption is not always as reliable as it should be. And overall, there's a reputation for Matrix being a bit geeky, a bit of a sort of socks and sandals open source thing that doesn't compete with mainstream solutions and being a bit hard to use. So, this is what we set out to fix with Matrix 2.0. So the whole mission here is to make it as fast and as usable as the mainstream alternatives. This meant a whole bunch of new APIs. First of all, completely change how sync works. We call it sliding sync. Secondly, add native group voice and video. Thirdly, switch our authentication to be OpenID Connect so that we get two-factor auth, multi-factor auth, YubiKeys, whatever existing things we can inherit straight from the OIDC community rather than wrapping our own authentication. And then finally, completely fix our crypto to the extent of calling it invisible crypto. We want it to be as invisible as Signal's encryption, or iMessage, or even WhatsApp, where the users have no idea that it's end-to-end encrypted because it just does it. And like Matrix historically, which could often say, oh, sorry, I can't decrypt that message, or I don't have the keys yet, or you need to do a weird verification thing that we don't understand in order to try to work. Instead, it should be completely transparent. And finally, it should be written in Rust. It should be audited, it should be well understood, it should be robust. And so that is why we built it on Matrix Rust SDK with this new SDK crypto crate implementation. So the big news is that as of September the 20th, 2024, these are all implemented and usable. The slightly bad news is that whilst the Matrix spec changes have stabilized and are on track for final call for proposal to merge, they're not actually merged into the spec yet. So I'm cheating a bit by saying that Matrix 2.0 is here because it's not actually in the spec, but the implementations are here enough that everyone can play with it and see how well it works. And then as we go through the final process of polishing the spec, it will eventually land in the coming months. We will bump the major version of the spec to be 2.0 when these and their various dependencies merge. So, here comes the science bit. Simplified sliding sync. The whole idea here is that the server should only tell the client about the rooms the client needs to display. So the reason that my account takes 20 minutes to log into is because it sits there downloading all of the metadata for all 8,000 conversations that I'm in, even if it is some random Telegram chat that I glimpsed at 10 years ago and then decided to lurk in. You know, if that's got 10,000 users in it, then it's going to still sit there, burning time, burning resources. We do lazy load the membership of these rooms, but it's still an awful lot of processing to take these all down to the client. So instead, the whole idea is that we will paginate everything, we will lazily load in only the rooms that you care about. However, it's been a bit of a wobbly ride, to say the least. First of all, yours truly had the brilliant idea that this should be all calculated server-side, and that clients will get a sliding window, and it will receive operations to update that sliding window of your room list, and if necessary, fix up the ordering client side. This was very strongly influenced by Discord. If anybody knows how Discord works, the way it gets its incredibly good performance in these massive rooms is that all of the lists are basically a little state machine where the server can go and insert and delete and switch and reorder things as needed depending on what is happening in that room list. It never downloads the whole room list. So it's even better than like gradually paginating it in. It's this very fancy thing where the server is managing all of the order for you. Now, there turned out to be a minor flaw in this amazing plan, which we discovered after having implemented it about 3 times over, which is that clients are the only things in Matrix that actually know the correct room list order. Because the rooms are end-to-end encrypted, the server can't reliably give the correct order, and so you can't go and visualize it correctly on the client. And so rather than trying to fix it up on the client afterwards, which then becomes horribly fragile, instead we have simplified the whole thing, and effectively now the way sync works in Matrix is that it paginates. So it just goes and does a rough ordering based on timestamp, and then the client goes and does all of the correct, fine, detailed ordering. But we no longer have this idea of a sliding window that moves up and down the room list. And honestly, it is a transformative improvement, which I will demonstrate in a second. Secondly, OIDC. We're now calling it next-gen auth. The whole point here is to realize that Matrix is a communication protocol. It's not an authentication protocol. And whilst we do have auth in it that is very similar to OAuth 2.0, it doesn't benefit from all the effort that you get from the OpenID ecosystem. And we embarrassingly started to sprout security issues, which OIDC had already fixed. Therefore, we are moving everything over to using OIDC as the APIs. It's not SSO, it's not social login, although you can use it if you want to for that. Instead, it's basically next-gen auth APIs. And it is interesting to see that both XMPP and the Blue Sky folks at Proto are also in the process of moving everything over to OIDC for auth. And in return, you get login via QR code, complete with all of your encryption state. You get 2FA, MFA, passkeys. No more implementing these weird Matrix auth APIs on every client you write and every home server that gets written. Users are now handing their password to the server rather than randomly handing it to a client that they just pulled off GitHub and prayed that isn't malicious. You get consistent auth and account management across all the different apps. You can, for instance, just automatically log in on new clients if you're already authenticated with your identity provider without either having to type in a password, etc. Right now, this is written in Rust as a separate module called Matrix Authentication Service, but it will be integrated natively into Synapse in future. So, sorry for all the words. Let me show you something a bit more concrete. If we flip back here to my test account, and I'm going to plug in my phone and pray that this horrible operating system, and I do apologize for using the wrong operating system while standing here, is able to actually display my phone at the same time. And you get to see me, hello. Right, there we go. So, now we're on TV. If I go and take element X here, that's what you see on iOS right now. And you may see that it now has a sign in with QR code button. If I go and hit it, it says open element on another device to get the QR code. And if I open element here, I have this link new device on element web. I can go and click on it. I can go back, ready to scan, and embarrassingly move that out the way, and you can see if I scan it like so, it gives me a check code, hit continue, nice, and now what we are in is in the Matrix Authentication Service, OIDC identity provider, which is saying, do you really want this iPhone to have access to your account? They will be able to see all of your messages and be you, basically. And I'll say, yes, I do trust that. I grant access. And then that's it. On my phone, I'm now logged in. And you can see now I'm on TV, I'm here too, I'm the Debian guy, etc. So it's one of these frustrating demos because it's almost anticlimactic. It's so simple. If you were logging in Matrix 1.0 mode, first of all, we're going to have to remember what server I'm on. You'd have to manually remember that this account is actually on element.io, it's not on matrix.org. Then you've got to remember your username. Then you've got to remember your password. Then you've got to verify this thing somehow, perhaps using a recovery passphrase or doing a different QR scan or whatever in order to go and synchronize everything together. Whereas now we literally have a single button which is synchronizing all of your end-to-end encryption, doing an instant sync, an instant login via sliding sync, as well as using OIDC for the auth under there. And If I go, say, into my settings here, I can look at my various sessions. It's given it some pretty ugly session IDs which we need to improve, but one of them, last activity at 1729, is going to be me signing in on that IP address, and if I want to, I don't know, kick it out from here, then it will actually take me through to the IDP where I can go and mess around with it some more and sign it out, etc. So this is the way of things to come here. Right. Where was I? So other things in Matrix 2.0. Native VoIP. So we're finally migrating from the old legacy mix of native matrix one-to-one calls in Jitsi to there basically being a single native matrix VoIP standard. This is called Matrix RTC, imaginatively, and it's Matrix Spec Change 4143. And what it allows you to do is to basically signal both VoIP calls and conferences over Matrix using end-to-end encryption. Now, a bit controversially, it deliberately supports multiple different backends for the media layer. So this, I see this a bit like end-to-end encryption agility. You don't want to put all your eggs in one basket. So for end-to-end encryption, today we use Signal Protocol, the double ratchet, with Ohm and Megohm. But we also have an evolutionary branch looking at MLS, IETF, RFC 9420, which defines a completely different way of doing end-to-end encryption. So likewise, for Matrix RTC, we have two backends. We have full mesh, where every device just goes and calls every other device at the same time, which works, but is not massively efficient in terms of managing all of these overlapping calls. But we also support LiveKit, which is a fun Golang project implementing selective forwarding unit, conferencing servers, as well as SDKs for accessing that from existing platforms. So Matrix RTC effectively gives you a way to coordinate an existing media platform within a matrix room, including end-to-end encryption. So I'm not going to risk setting it going here in the Ubuntu Summit room, just in case something hilarious happens. But if I go to some test room here, I have my video call button here. And at the moment, we provide two buttons. You either get the legacy call or element call. Element call is the implementation of Matrix RTC. So let me go and set that going like so. And hello, Mum, I'm on TV too. If I go over to my screen share, which is still running here, you can see the same conversation. Now, I was trying to test this demo earlier, and it was comically not working at all, probably because of a bug on iOS, which means I can't capture via USB and do WebRTC at the same time. But let's see what happens if I try and hit the join button here. Right. Okay, it's not looking too bad. I've got, well, at least it's working on my phone, but you see what I mean about it all going horribly wrong because it's no longer managing to screen capture whilst working on my phone at the same time, which is a bit annoying. Probably work better if I actually capture video there. Ugh. You know, what I'll do is use the analog gap to hopefully show you what's going on. That said, it's got sufficiently upset that it doesn't have audio there, video there. Let me reconnect here. Talk among yourselves for a minute. Right, there we go. So it works fine if I'm not actually capturing on QuickTime. So this is a fairly basic one. You can see me on my phone here as well as on the screen. But if I, for instance, set a screen share going, I'll just go and capture my whole screen for expedience, then that gets chucked in there too. Now, first of all, I'm participating in this conference in two different devices as the same user and a screen share. So it's not a basic one-to-one call anymore. And if there were multiple people hanging on around in here, you would be obviously seeing lots of people. It will go up to at least 200 or 300 users, thanks in part really to LiveKit, which has some nice negotiation stuff where it only sends and receives the video for the people who are physically visible on the screen at the resolution that you're currently requesting them at. But if I hang up on this guy, and I had developer tools turned on, oops, So I'm going to show hidden events in the timeline here. Then we can see what was actually going on under the hood, because there's a whole bunch of signaling happening here. And some of this is me testing earlier, but this is actually where that call began at 1735, where there was a call notify, and you can expand these up if this is at all visible. And you can see that basically I started a call ringing in that room, and it had a bunch of and even that event itself was encrypted, because we see it in both its decrypted form and its encrypted form. Then we start sending end-to-end encryption keys into the room, because each media stream was being encrypted. And yeah, there is literally the key that was being used for one of those streams. And every time the participants of the call change or some time elapses, the keys are getting rotated there, so that you're basically using Matrix itself as an end-to-end encrypted communication layer to coordinate the encryption keys that are then used for the voice and video, so that you get end-to-end encryption all the way around. And you you anchor the trust of the VoIP and video streams in the existing trust that exists inside Matrix. In my opinion, this is pretty cool, because it finally converges everything into a single security model, and is very much the shape of things to come. This will be turned on Element Web by default on Monday. So we didn't quite get it out there a few weeks ago, but we are going to be at least making that video button do the right thing. And meanwhile, Element X on mobile doesn't support the old calling system at all. What other things could I be showing you? I should have shown you on the phone, where we have things like picture-in-picture and other nice stuff, but I'm running low on time, so I will not show that. So, architecturally, this is what was going on here, that you basically have your Matrix servers and clients, but we also now have these LiveKit SFUs, which are multiplexing together the media streams. At the moment, you focus on a single one, but in future, you will be able to focus on multiple ones. So you basically have a mirror world similar to the normal Matrix traffic, but for voice and video, decentralized in the same model. Then finally, encryption. As I said, it should be invisible. First of all, we've had to massively improve the reliability with Rust SDK and our Vidosmat's Rust implementation, and a really, really nice test framework called Complement Crypto, which goes and does integration testing inside Docker of the entire stack. So it will put client SDKs and real servers over federation together in a simulated network. It will break things, you have a failing test, you fix it, and you move on. And so for the last year and a bit, there was a lot of time just spent going and fixing, or writing failing tests and fixing them. And nowadays, we are pretty confident that the encryption is working as well as it possibly can. So to make it invisible, we are going to require that everybody verifies that they actually own their device, which should have happened all the way along. It's a bit silly that it didn't. The only reason it didn't is because of the transition to encryption back to 5 years ago for Matrix 1.0, whereas now we are finally doing the thing where we ignore anybody who hasn't done that transition. We're saying everybody else going forwards needs to verify that they actually own their devices. And then we will no longer encrypt for untrusted devices. So once this lands, basically, if you have not actually set up encryption properly on your client, you will no longer be able to receive or be decrypted, which hopefully will be an acceptable trade-off in terms of finally proving that people are who they say they are, or people's devices are owned by the people who claim to own them. Then beyond that, no more weird gray shields, and there's a bunch of MSCs to avoid authenticity could not be determined on this device error, whatever that meant. And then other things include dehydrated devices, which means that you have the option to keep a logged-in device on the server, so that if you log out of all of your Firefox tabs, you can still receive messages because you can grab the device off the server. Then there is sharing history when you join a room or a space that needs to be done. And finally, trust on first use and key transparency, so that even if you don't explicitly verify other users, you get good warnings if their identity suddenly changes. So in diagram form, back in Matrix 1.0 world, we would have classic, say, element iOS built on top of the Matrix iOS SDK using Jitsi Meet, connected to Jitsi Video Bridge for video calling and conferencing. It would be using libOhm, our old C and C++ and now deprecated encryption library inside a bunch of Objective-C called MXCrypto. We had a UI kit, UI written in Matrix kit, and then we would use Realm for storage and core data and also file store module. And on the right-hand side, you have Synapse written in Python with a whole bunch of different workers, processes talking to Postgres, federating with other Matrix deployments. Whereas in our brave new Matrix 2.0 world, the left-hand side completely changes. There is literally not a line of code in common. We are now built on Rust SDK, both on Android and iOS. We had to write the async UniFFI bindings for Swift and Kotlin in order to expose the async Rust up nicely to the Swift and Kotlin layers. We have Dosmats for native Rust crypto. We're using SQLite and SQL Cipher, I believe, for storage. And then we use SwiftUI on iOS, Jetpack Compose on Android, and Element Call for the actual VoIP calling. Then authentication via Matrix Authentication Service as the OIDC IDP written in Rust, which will get moved into Synapse, although can also be used externally. We now have sliding sync workers here. There are also work underway to replace some of the Python workers here with Rust. So Synapse is basically corroding in the way that Python sometimes corrodes into Rust. So, welcome to Matrix 2.0. All of this is live on beta.matrix.org today. You can also run it all yourself. It's rolling out incrementally on matrix.org, so if you're using a matrix.org server, you don't yet have Matrix auth service, sorry. It will be there hopefully by the end of the year. But things like Element Call, as I say, are now being turned on Monday. So, I've got about 5-ish minutes left. I thought it might be of interest and topical to talk about how do you fund a project like Matrix. And I'm sure this is something that comes up a lot. The whole point of Matrix is to be this communication layer of the web, and that's what we set out to build. So we started off with Apache licensed implementations of the Matrix core project. However, always knew that the protocol would need a killer app in the way that, I know, IRC and XMPP never really had a killer app. So we chose to build this as Element, as a separate for-profit project and startup. So Element was set up to hire the core team so that we could keep working on Matrix. And then we set up the Matrix Foundation to be this neutral, non-profit custodian for the protocol. Now, Element donated the vast majority of the dev to the foundation because before Element existed, we were nothing but Matrix, and so we basically kept being nothing but Matrix, even if the day job was technically working at Element. However, turns out that selling a pure Apache licensed open source project in order to keep the lights on is hard. So what happened is that Element, first of all, created a SaaS hosting platform called Element Matrix Services, and nobody used it, really, because it turns out that the main reason to use Matrix is that you want to host it yourself. So the convenience of having SaaS is not quite as large as one would expect, particularly for big, large deployments. So then Element went out and created an enterprise Matrix distro called Element Server Suite. However, it turns out many folks are happy to use their own distro, which is fine. It's open source. I saw that Canonical have written their own Synapse operator, which is absolutely fine. What isn't so great is when some kind of system integrator does this and then promptly competes commercially with Element and basically price bombs the entire market, saying, well, we can just pick up Element stuff off GitHub and charge you peanuts for it. And obviously the reseller, or not reseller, the taker in the ecosystem doesn't have any of the development costs, and so they can charge whatever they like for it without having to actually go and contribute back to the underlying costs. And last year, this all went increasingly wrong because it's just not sustainable for Element, because Element was shouldering all of the dev costs for doing all of this amazing tech and then unable basically to get people to buy solutions for it if they're picking up the Apache license things and price bombing. So last year in December, Element switched over to AGPL from Apache for development and switched development to the server implementations like Dendrite and Synapse to be done as Element rather than as the foundation. focused exclusively on building for governments, hence the slightly unexpected segue into governments earlier. And Element had to pause all of the long-term matrix R&D until new funding comes in, which is basically breaks my heart because there was a lot of really, really promising long-term stuff, like full peer-to-peer matrix running over Bluetooth Low Energy, where the server runs inside your client, so you no longer need a server. Low bandwidth protocols, account portability, pseudo-IDs and cryptographic IDs, which are necessary dependencies for account portability. Post-quantum encryption, the MLS work, all of the spatial computing over matrix, the second generation server, etc. All of this is basically on hiatus whilst Element is focusing on Element X, Element Core, and the stuff I've been demoing today. Meanwhile, on the foundation side, the Matrix Foundation has started fundraising by selling memberships. Now, good news is that things are looking a bit better on the Element side, not quite out of the woods yet. On the foundation side, it's not looking so good. The foundation is explicitly losing money at a slightly alarming rate. So on the foundation side, the way it works is that the foundation sells memberships, and as an organizational member, you get to help support protocol development. You actually get to stop the foundation losing money, get to participate in the governing board, you get conference tickets and blog posts, and generally your name in lights. And you can see that we have a bunch of them. Weirdly enough, Element is the platinum one, but also Beeper, FutureWay, Faircom, Famedly, Fractal Networks, Schematic, and indie hosts, Virgi and XWiki, and also 800 individual members have signed up to help keep the foundation running. Basically, the TLDR is that if you are commercially benefiting from Matrix, it's very, very helpful to be a member of the foundation, even more so if one contributes to the dev costs on the Element side by buying stuff from Element. So on the government side, it's kind of interesting in that, as I said, there are lots of governments using this. Some of them donate a lot. For instance, the German government with Bundeswehr Messenger is probably the largest financial support to the Matrix core team currently. There are things like OpenDesk, which is another German initiative from the Center of Digital Sovereignty, Zendis, who's contributing. You have the UN, Sweden, US government, NATO, UK, a little bit from the Netherlands, also some educational ones like NRW. You also have some coming in from France, where the entire public sector is running on Matrix now via chat. You also have a whole bunch of others who are using the tech in production and not necessarily contributing any funding back at all, which obviously forms some sustainability problems. Meanwhile, on the open source side, loads of people out there, I think basically all Linux distributions to some extent now have Matrix presence. You have folks like Mozilla and Wikimedia as well. Blender just moved over, and obviously Ubuntu.com too. So what's next? We need to do a rework on state resolution. There are a couple of slightly nasty inconsistencies that have emerged, but we're actively working on them, and we'll be releasing either a state res 2.1 or 3 in the coming months. We need to ship all of the invisible crypto. We need to keep improving performance and usability, really try to find funding from somewhere to work on account portability and multi-homing again. And then perhaps 5 years from now, it will be Matrix 3.0. And honestly, this is an open question as to what it should be. Should we focus entirely on trust and safety in Matrix? Should we focus on completely revamping the encryption and moving over to MLS? Should we converge with the IETF's MIMI, which is the more instant messaging interoperability working group work? Don't know. Place your bets. So we need help, if it wasn't obvious. Friends don't let friends use proprietary chat services. If you benefit commercially from Matrix, please financially support the foundation. Run a server or get an enterprise one from your favorite supporting vendor. Build bridges, bots, build something cool on Matrix. Follow us on Mastodon or Blue Sky or anywhere, and spread the word. And thank you very much. So I said I wasn't going to run late, and I proceeded to run about 12 seconds late. I don't know if we have any time for any questions.
Do we have any questions?
We have microphone number 1, microphone number 2. I see someone on microphone number 2. Yes, please, your question.
So, as individuals that don't use Matrix commercially, how can we help make the foundation more sustainable?
You can absolutely join as an individual member. I would probably remember the price points off the top of my head, but I can't directly. It means that you can vote in the foundation and help select who goes into the governing board. And honestly, the more individual supporters we have, it almost acts as a force multiplier for getting larger donations, because we can say, look, we've got 800 people who think this is a great idea. Can you please match everything they do tenfold? And it's a much easier ask. Also, if you don't have money, contributing in some way, whether it's advocacy, filing bugs, really useful, keeping us honest on the bugs which are open, or just using it as a project is obviously good too. Thank you.
Thank you so much. We have time for maybe 1 or 2 more questions. 2 more questions.
Matrix's big thing is that it connects to many different solutions, right? Mm-hmm. But the big customers that you now seem to have are the governments. Are they also using it to bridge it into different services, or are they using it as a solution themselves?
It's a mix. So a lot of governments already have Skype for Business, and Skype for Business is a zombie at this point. Microsoft keeps keeping it lurching along whilst trying to get everybody to move to Teams. But obviously, if you're the Swedish government, you are not going to move to a Teams deployment run in the US by an American company. It would be insane for your government to operate as a dependency of someone else's. And so bridging to Skype for Business is one thing that commercially Element is up to. Also bridging to XMPP, because things like NATO use XMPP today. A certain very, very large defense department uses a lot of IRC, 1.5 million IRC users. And so bridging through to IRC in a government context is also important. The problem is that when you bridge, you always lose the end-to-end encryption. So you're missing out on a lot of the good stuff. But if practically, I don't know, you've deployed chat servers on ships in a navy floating around the sea or submerged under a polar ice cap or whatever they're doing, it's going to be hard to upgrade them to something like Matrix. And so necessarily you have to bridge with what is there already. So yes, TLDR, yes, it's one of the useful things that Matrix helps them with.
Okay, thank you.
One last question.
I love membership idea. Are there any brag tags to make sure that my user account has membership and that the room has room membership and that the server has server membership? Because that would be nice, because I want to only talk to people who have membership.
Yeah, this is one of the probably sorest points in all of Matrix, that once upon a time we had this thing called communities or groups, which came with flair, as we called brag tags, because we all like office space and imagined lots of flair badges on people. And it was a disaster as an API, because it was this very custom set of APIs purely for managing flair and group memberships. And one day we realized that your membership of a group should basically be membership of a room. So we replaced it with a concept called spaces, where you can group rooms together and you can indicate membership of a space and all that stuff. We have not yet got round to reintroducing flair, and it makes me very sad, because without brag tags and the like, you're really missing out on a trick. We can lock down rooms, though, to membership of particular spaces if you do want to create a cult of some kind, or some kind of access control system. But yeah, it would be really nice to have proper, nice branded flair so everybody gets a warm, fuzzy feeling.
Yeah. I don't care about ACL. I just want to see warm, fuzzy feelings.
Yeah, we need a lot more warm, fuzzy feelings. Thank you.
Thank you for your question. Thank you so much, Matthew. Well done. Okay. While this is a wrap-up of the sessions that we have today, the day is not over. If you are a volunteer, you can be, and you love your VDBs, listen to this song and you'll reach divinity. Be the victor you can win if you proclaim with glee. Veni, vidi, vici, vidi, vi will see. If you're a volunteer, you can be, and you love your VDBs, listen to this song and you'll reach divinity. Be the victor you can win if you proclaim with glee. Veni, vidi, vici, vidi, vi will see.
Okay.
you folks have come long distances, whether it's, again, flying from around or just walking from somewhere nearby. And we have a welcome reception here as an evening activity. We'd like you all to take part in it. It's starting at actually 6 p.m. All the way to 8 p.m. So it's right here at the World Forum. And I think maybe one last reminder, every year at the summit, we have this tradition where we do a group photo that involves everyone that's actually attending. And every year we kind of like break the record of how many people we could fit on the stages of the venues that agree to have us here. So that group photo is going to be at 10 a.m. tomorrow, which is day 2. And that's a wrap. Thank you for joining us today. Thank you for helping us kick off Ubuntu Summit 2024, day 1. And if you'd like to learn more, you can find it in Indico. You can find it with this QR code. I'm just glad to see you all here. And thank you so much. Have a good evening.